What's up, everybody? Welcome back to another live stream from the Scalar Learning Channel. We are back. We have a SAT tomorrow, and we're going to do a long, lengthy stream where we're going to rip through a bunch of the new practice tests. I am just making sure we are officially live here. Give me 1 second. Yeah, there we go. We are live. We are back at it. Welcome back, everybody. I hope you guys have been enjoying a lot of the shorts that we've been creating. Also, we are starting to do some calculus content. We know that AP is coming up next week, so we're going to be making a ton, or what is that, 10 days, I guess. We're going to be making a ton of AP Calc content to get you guys ready for the AP Calculus exam. But we're not here for that today. Today, we are here to talk about the SAT and the math section of the SAT in particular. So there are four new practice tests, but 3 of them that I have not taken yet. So I figured I'm going to bang them all out in one go. Best time, right? SAT is tomorrow, Saturday, May 3rd. So we're going to rock out all these math sections back to back to back. And then at the end, we're going to talk about trends that I noticed. I've already taken practice test 7 on the channel, but we're going to talk about trends, and I'm going to use that to make some predictions for what I think you guys should prepare for and expect tomorrow on the SAT. So that's it. Without further ado, if you guys are new to the channel, what I do in these streams is I take the test for the first time in real time. So I'm going to have the timer on. I'm going to do my best. Any mistakes that I make, we'll figure it out when I go back and check the answers at the end. And we'll go back, make sure we understand those mistakes. And that's it. Learn from those and move forward. But hopefully I don't make any mistakes or too many mistakes. But it is what it is. Sometimes they happen. All right, here we go. Let's jump into the mix. Make sure we are queued up correctly here. All right, so of course, this is going to be a math review, so we're going to skip through all the verbal sections. So let me just leave these all blank. Boom. Okay, that is mod 1. Let's keep it going. And let me know in the comments if you guys have particular questions in the live chat as we go through these problems. But here we go. Without further ado, we're going to start in 3. Oh, let me get a whiteboard up. So I'm going to use this for my scratch work. I'm going to start in 3, 2, 1. Let's go. Okay. There we go. What is the y-intercept of the graph shown? That is where it hits the y-axis. It is 808. That's how you do it. Y-intercept, boom, done. Number 2, the function f is defined as this. What is the value of fx when x equals -8? Plug and chug. -8 times -3 is 24 plus 60 is 84. This is just straight up plugging into the function, getting the function value, boom, done. Number 3, a producer is creating a video length of 70 minutes. Video will consist of segments that are 1 minute and 3 minutes. Okay, 1 minute and 3 minutes. Which equation represents a situation where x is the number of 1 minute, y is the number of 3 minutes? So what we're doing is we're taking these number of segments and we're adding them with these, and the total is going to equal our 70 minutes, okay? And that's essentially it. I'm writing the equation from scratch. I do not recommend looking at the equations and be like, which one makes sense? Create it on your own and then match it. And even if it doesn't match perfectly, you'll like, right, I have a 1 there, there's nothing there, but you know, in essence, it is correct, and then you can modify it and manipulate it as need be to find the right answer choice. There we go. Number 4, a bowl contains 20 ounces of water. When the bowl is uncovered, the amount of water in the bowl decreases. Okay, so let's check this out. A bowl, this sounds like a linear equation. 20 ounces of water, and then it starts to decrease 1 ounce every 4 days. So that's kind of like my slope, right? It goes, this is the rise, that's the run. And x could be number of days, blah, blah, blah. And y would be the amount that remains. Okay, so now I've created a linear equation. If 9 ounces remain in this bowl, how many? Oh, sorry, and it decreases by that amount. So 9 ounces remain. 9 would be y, and then we can solve for x here. And then we're going to subtract 20. We got -11 equals -1/4 x. Multiply both sides by -4. X equals 44. So that is our answer. Let's just think about that and make sure that makes sense. So every 4 days. So in 4 days, it would be 1 ounce. So 44, it would be 11. That would bring us down to 9. Verified, done. Number 5, each of the dot plots represents the number of glue sticks bought by each student in the class A and B. Which statement best compares the standard deviations of the number? Okay, so if we're just talking standard deviation, I've said this a million times, the way they test on it is they're not actually needing you to calculate it. You just need to understand standard deviation is spread. Okay, that is the spread of the data, specifically the spread from the center. But if you look at these two, while the numbers are different, The spread is exactly the same, right? But they both have a range of 6, okay? And the distribution is identical in both, meaning the standard deviations are going to be identical. That's it. If one was more spread out from the center, then you'd say that one has a greater standard deviation. The other one would have a less, whatever. So it's comparative. It's not specific. So anyways, not less. The standard deviation of glue sticks is equal to, yep, standard deviation is greater and not enough information. Nope, there is enough information, exact same variation. That's how you do it. Which expression is equivalent to this? Okay, let's combine like terms here, and there's a minus in front of that second term, so we got to distribute it. So it's going to be minus 6x cubed plus 3x. Combine like terms, 7 minus 6 is 1x cubed, 7 plus 3 is 10x. X cubed plus 10x, that's how you do it. Boom, done. In triangle ABC, so what do I say? Another tip, just go into autopilot mode. They said triangle, they didn't draw one. Let's draw it out. A is 54. B is, no. We're going to do a right triangle. Okay. I should have looked ahead to make sure it was right or not. So B is 90. A is 54. And C is, okay, so C is K over 2. So obviously we can figure out what C is because we have 2 angles, and all angles in a triangle add up to 180, right? So that's 90 plus 54 is 144. So this has to be, and you can use Desmos for this to do the calculations, this has to be 36 degrees. So then it says C, which is 36, is equal to K over 2. So what divided by 2, where we solve for K by multiplying by 2, and that would be 72. 72 is the winner. Done. What is one of the solutions? Oh, by the way, let me point something out here. You notice how they had 36? 36 is the actual angle, right? So that is another trick. You need to double check. Like, they're not asking for C. They're asking for K when C is K over 2. So that's one of the things that you need to check for, one of the little traps that they can set. All right, what is one of the solutions to the given equation? Okay, so this is equal to 0. Sorry. This is a polynomial. Of course, you could graph it if you're unsure of what it means. But basically, it's just saying what values of x will give us 0 here. So look. There's 3 different solutions because it's factored up into 3 factors. We've got what makes this individually go to 0. That would be 0. What makes this individually go to 0? That would be 4. And what makes the last one, negative 5 plus 5, would go to 0. So these are my 3 solutions. The only one I see is 0. I don't see 4, negative 5. That's how you do it. Done. A chemist combines water and acetic acid to make a mixture with a volume of 56 milliliters. Let me write that down. The volume of the acetic acid. Okay, so acetic acid is 10 milliliters. What is the volume of water in the mixture? Isn't it just 46? Wait, hold on. Let me make sure I didn't misunderstand this. Chemist combines 56 milliliters. So acetic acid and water. The volume of the acetic acid is 10. What is the volume of water in the mixture? I think it's just 46, unless I'm missing something. Hold on a second. 56. Yeah, I think it's just 46. Sorry, I am just second guessing myself because it seemed a little too clear cut for number 9, but it is what it is. Let's keep it rolling. A distance of 354 furlongs is equivalent to how many feet? All right, so they're giving us the conversion. So check this out. This is how I like to do it. I like to do it old school. So we got 354 furlongs. Now let's convert it. We need to convert it to feet. First, let's convert it to yards. It says 1 furlong is equal to 220 yards. Notice if furlongs is on top here, I got to have it on the bottom there so the units cancel out. Now I need to convert yards to feet, and it says 1 yard. Again, it's on the top there, bottom there. Is equal to 3 feet. Cancel, cancel. Now we just multiply, and we're going to get our answer. Let's use the calculator finally. So we got 354 times 220 times 3. Let's double check, make sure we didn't write anything down incorrectly. 23. Okay, hold on. Yeah, there we go. 233,640. That's how you do it. Boom. At how many points do the graphs of the given equation intersect? All right, I can tell you right off the bat, it's 0. You can graph it if you need to, but these lines are parallel because they have a different y-intercept, same slope, parallel. They never intersect. That's how you do it. Done. Different slope. I don't care what the y-intercept is. They intersect once. And if they are identical, obviously, then it's infinite. It won't be 2. You cannot, 2 lines will not intersect only twice. Okay, watch this. 13 is p% of 25. So of is our multiplication symbol, right? So we can write it like this. And then you can solve for P. We can divide by 25, multiply by 100. Another way you can do this is if you want to be slick. Check this out. 13, I think you can do it like this, wait, hold on. Let's see if this works. No, 13 is P% of 25, or no, we'll say X%. Let's see if this works. Okay, I think this will also work as well. Yeah, it works. So you can do it like that, or you can create the equation like this. You can do it step by step. 13 divided by 25 as you're isolating this equation on the left, and then you're multiplying by 100. So you get the same thing. If you guys like this is just like straight up using language to solve it. And then notice the answer outputs as a vertical line. You just have to see where that vertical line is. Oh, it's at 52. So anyways, that's it. The value is 52. Excuse me. So 52% of 25, that makes sense, is 13. Boom, done. The function f of t is this, gives the number of bacterial population. Okay, how much time in minutes does it take for the number to double? Okay. This one I can tell you right off the bat without doing anything. It's 410. The reason why is because we got a 2 in there. So every time this iterates by 1. So, when this quantity is 1, it doubles once. When it's 2, it's going to double twice. And because it's over 410, I know 410 over 410 is 1. 820 over 410 is 2. So those will be the times when it doubles every, what is that, in minutes? Every 410 minutes. Now, if you're unsure, a great workaround is something I call the table method, which I've talked about. You can plug this in and you can say, all right, when t is 0, you're going to see that actually, let me show you. I have the time. So watch this. If we say 60,000, right, times 2 to the let's say it's 0 over 410, right? So it outputs 60,000. So then you can be like, all right, when am I going to, I want to know when this thing is, I forgot, you can't copy and paste in the College Board version. We want to say, when is this going to be double the 60,000? You know what I mean? When is it going to hit 120,000? So you could be like, is it 50? No. Is it 100? No. Is it 410? Oh, look, it doubles to 120,000. So it took until this goes from 0 to 410. And so that's a workaround if this is not as straightforward for you. Okay. Number 14, each year the value of an investment increases by this from the previous year. Which of the following functions best model? Okay. Of the previous year. Okay. So it says increases. That means we're not talking decreasing. We're not talking decreasing. The question is it linear or exponential? Now, if it's increasing by the same amount every year, linear all day. But this says 0.49% of its value the previous year. That's a moving target, right? So let's say first you increase by like $100, okay? Then the previous year it increased by 100. Now you're increasing by 100.49. Then it's going to be 0.49% increase of 100.49. So the value by which you're increasing is changing. That's getting bigger every time. So that would be increasing exponential. All right. 15, a circle in the XY plane is a diameter with endpoints, blah, blah, blah. I'm going to draw this out very quickly. Okay. So we have, what is this, diameter? Okay. So we have 2, 14, and they're right on top of each other, 2, 4. So you can see the diameters from 14 to 4, which is 10, right? An equation of the circle is enclosed. Okay, what is the value of R? So they want, all they want is R. They don't care about this. Well, actually, they did give the center, 2, 9, but they don't really care about that. They want our R value, okay? And that's, R is radius. That's it. And you should know that from my formulas video. But so if you look at my diagram, if the whole thing is 10, the radius is half of that, which is 5. And that's it. Boom. Now, if you wanted to, just for fun, you could also plug, or if you needed to, you could plug this into Desmos. You could try various values of R, and you'll see that only 5 will give you these correct endpoints at 2, 4, 2, 14. So I like to give all my students lots of backup options and ways to tackle these problems if you don't know the traditional or quickest way to do them. All right, in a right triangle, RST, the sum of the measure. Okay, so check this out. RST. The sum of the measures R and S is 90 degrees. So R and S are these ones, and then T is obviously the 90, okay? Then it says the value of sine of R is rad 15 over 4. So if we remember sine in from SOHCAHTOA, it's opposite over hypotenuse. So we could say the opposite side is rad 15, the hypotenuse is 4. And you might say, well, wait a minute. It could be 2 rad 15, 3 rad 15. It could be 8. It could be 12. Yes, that's true. It doesn't really matter. For the sake of this problem, we can as long as we choose ratios or values that have the correct ratios, it's going to work for the intent and purpose of this problem. Now, next, we're trying to find what is cosine of S. There's a shortcut in this problem that says if we know that two angles are complementary, sine of one is equal to cosine of the other. So I already know my answer is the same. It's rad 15 over 4. But if you didn't know that, again, you can finish the triangle, right? So it's like we got to draw out. Now I want cosine of S. What is cosine? So that is adjacent over hypotenuse. Oh, double verified, rad 15 over 4. Boom, done. 17, here we go. The given equation relates distinct positive numbers pkj, which equation correctly says 4j. Okay, so this is just straight up isolation, right? So we're trying to isolate 4j plus 9. My first thing, as it's on the denominators, I'm going to multiply it to the left side. We get p times 4j plus 9 is equal to k. Then to isolate this quantity, all we got to do is divide away the p, right? Don't distribute it here. That's just going to make it harder for you. We got 4j plus 9 is equal to k over p, and that's our final answer. A is the winner. Done. Isolating quantities, that's that. Now let's move on to this one. Virtual defining tables are relevant. Okay, for these, I know people like to use Desmos. I just like to plug and chug. So for example, I look for violations. So let me show you what I mean. I have made mistakes on these problems before too with this method. So because I go a little fast and you should really take your time and double check if you're doing this on the real thing, but check this out. Plug in 21, plug in 3. 3 times 13 is 39 minus 18 is 21 on the dot. 21 is not greater than 21, so we can cross this guy off, right? Okay, next, 326. I already know that's going to work, right? 39 minus 8. I'm doing it mentally. You can do it with the calculator, but I'm just doing it mentally for fun. 26 is greater than that. Yes. Is 42 greater than 5 times a 65 minus 18 is 47. No, this one is out as well. Okay, well, then 542 doesn't work. So it has to be this one because they had 542 twice. Okay, I am going to double check because I didn't make mistakes on these before being too hasty. Hold on. Too much mental math here. Okay, so we got, let's see, 26 is greater than 39 minus 18, which is, yes, that's 21, so that works. Then we've got 52 is greater than 65 minus 18, and that is 47. That works. And then we've got 91 is greater than 8 times 13 is 104 minus 18, which is 84. 80. So yeah, that works. D works. Okay. But that's it. You could do that. Again, also one other way, you could plot the inequality and you could check all the points one by one because this inequality will give you that shaded solution set of y is greater than that line. That's another way to think about it, but that's pretty much it. 19, line L is defined by this. Line N is perpendicular to line L. What is this? Okay, here we go. So, perpendicular, lines that are perpendicular, the relationship of the slopes are they are opposite reciprocal. So, I need to know the slope of this line. You can plot it in Desmos or you can put it into slope-intercept form. I'm going to do the latter. So, we're going to minus 12x and plus 5. We're going to divide by 3. We got negative 4x plus 5 over 3. Here is my slope for this line. It's negative 4. I said the opposite reciprocal for a line that is perpendicular to this is we first make it positive 4 and we take the reciprocal of that, which is 1 over 4. That's how you do it. Number 20, in the given equation, D and G are unique positive constants. When the equation is graphed in the xy plane, how many distinct x-intercepts? Distinct, not repeating. Okay. So when they're talking about x-intercepts, that's when the value of y is equal to 0. So what's going to make this go to 0? When this is 0, this is 0, this is 0, this is 0. So the 0 here for this one is going to be D, right? D minus D is 0. We'll zero everything out. I don't care what any other, quantity becomes. For this one, it's going to be negative D. Negative D plus D is 0. For this one, it's going to be negative G. For the last one, it's going to be D again. So they said unique. If they did not say unique, we would say 4. But since they said unique, we only have 3. 3 is the winner. Done. For the exponential function f, the value of f of 1 is k, where k is a constant. Which of the following equivalent forms of the function f shows the value of k is a coefficient? Okay. All right. So hold on one second. The value of f1 is k, blah, blah, blah. Which of the following? The value of k as the coefficient or the base. Oh, got it. Okay. So when we plug in f of 1, got it. Okay. This is a weird question. I know the answer. It is going to be C, but let me explain why, okay? So they're saying the value of f of 1 is k. And then they're saying that k is a coefficient of the base. So what are the coefficients in all of these options? 50, 80, 128, 2. So the base is this number in here, 1.6. The coefficient is this number in here. So what we're trying to figure out is for which one of these, when I plug in 1 for x, do I just simply get a function value of the coefficient? It's not here. Because when I plug in 1, I get 1 plus 1, which is 2. 1.6 squared times 50 is not 50. So this one is out. For this one, if I plug in 1 again, it's not going to return me 80. It's going to return me 80 times 1.6 to the first. Can't be this one. And likewise for D, if I plug in 1, it's going to be 1.6 to the negative 1. That's 1 over 1.6. It's not going to give me 204.8. But this one will work. And the reason why is because when I plug in 1, 1 minus 1 is 0. 1.6 to the 0 is 1. 1 times 128 is, of course, 128. And you can use Desmos as well by writing this out if need be, right? You can type in f of x. You can plug in, you can say then f of 1, and you'll see what it outputs. So you can leverage Desmos. Of course, it's way faster if you remember these principles. But those are a couple ways to do it. Let's go to 22. We've got 16 minutes left. Doing good. Function g is defined by this. For what value of x does g of x reach its minimum? Okay. I'm going to show you the Desmos way to do it because it's just going to be so much easier. So check this out. Desmos is really cool in this respect. You have f of x. So you type it in literally exactly as it is. Okay. Plus 64x plus 262. Now, I will tell you, if you know your transformations, this is a transformation of 5 to the left. So you can look at this and be like, okay, well, this center is here. The minimum is at -8. This is transformed 5 to the left, so it's going to be at -13, which is A. Or a slicker way to do it, so you don't even have to risk misremembering the transformation. Literally just type it in. It's saying f of x plus 5. I typed in f of x plus 5. Let's turn this one off. And now we're looking for what value of x does it reach its minimum? -13. Boom. So I think that one is really slick, and it doesn't take that much time. So it's a great first method, a first option in terms of solving. And that's how you do it. We got mod 1 done. Hold on, let me take a sip. All righty. Here we go. We are going to hit next. We're going to go into mod 2. And if you guys are watching right now, if you could give this video a like, I would really, really appreciate it. It helps the channel. All right, here we go. 3, 2, 1. This is good enough. Zoomed in. All right, which equates to the same solution. Let's -6. We got 4x equals 12, x equals 3. So which one of these is x equals 3 as a solution? C is the winner. Boom, done. We're going to go a little faster here because I'm going to be pressed for time on mod 2. Total cost f of x, the lease car for this is this, where x is the monthly payments in dollars. What is the total cost of lease a car when the monthly payment is $400? And it said, where does it say? X is the monthly payment, plug and chug. So we got, you know what? I'm going to do it like this. Keep it simple. 36x plus 1, 2, 3. And then we want f of 400, right? When x is 400, we got 15,400. That's how we do it, pure Desmos. If the graph of this is shifted down 5 units in the XY plane. All right. Another way we can use Desmos really nicely here is as follows, right? Of course, if we just had this in slope-intercept form, this would be super easy, right? We just drop the y-intercept, but we don't. So check this out. Here is my original function. Yeah, I can't copy and paste. I forgot. And then now let's try and shift this down, right? So, and actually, we can just look at the y-intercept and say it's going to be at 4. But if you want to actually, if it's like something different, it's saying, hey, we actually want to shift this thing down by 5 units. The way you do that is you modify. It's kind of like in a circle, right? When you do +5, it's actually going down by 5. If it's in standard form like this, you can just add 5 to the y, and you see how it shifted it down, and we got exactly what we predicted, which is 4. So that's another way to think about it, but yeah, that's pretty much it. We got a y-intercept, of 4. Boom, done. Well, let me make sure I didn't misunderstand that. Shifted down if the graph, yeah. Okay, we're good. Number 4, the function is defined by this. What is the y-intercept? The y-intercept is straight up this value right here. It's in slope-intercept form, so it is -2, 0, -2. B is the winner. Boom, done. 5, the graph shows the relationship between the number of shares of stock from company A, X, the number of shares of stock from company B, Y. So that's B and that's A. With which equation represents this relationship? So first of all, I have a negative slope. It can't be A. This is a positive slope. Can't be C. That is a positive slope, right? It's got to be one of these two. And you see that if I subtract 8 and divide by 12, I will get a negative slope. Same here. Subtract 12, divide by 8, I'll get a negative slope. Okay, without turning it into slope-intercept. Okay, I can figure this out really quickly, right? So this is up top here. Hold on one second. 48. So here we have a y-intercept of 40. So if I plug in 0 for x, y would be 40. It's probably b, but let's just double check. If I plug in 0 for x, here y would have to be 60. That's incorrect. If I plug in 0 for y, x would have to be 40, but it's not. The x-intercept is 60. And here that makes sense. 60 times 8 is 480. B is the winner. Boom, done. Okay, the solution to and you could have graphed those in Desmos if you weren't sure. The solution to given system equations is xy. What's the value of this plus this? Okay, this is, wait a minute. Okay, this is what's called a little layup, all right? Now, you might be like, all right, I'm either going to plug this into Desmos, solve for x and y individually, and then figure out this crazy expression. Okay, that will work, all right? But a lot of times when they have these expressions, what is this weird thing plus this weird thing? If you take a closer look at the equation, there's going to be something special, and here there is something special here. If I multiply the bottom equation by 2, okay, I get 10 over 2x plus 12y is equal to 46. And I recognize that because I'm like, how do I get 17 over 2x? It's usually by adding these equations together, but here we had to slightly modify and then add. Look what happens now. When I just add these two together, 7 over 2 plus 10 over 2 is 17 over 2. 6 plus 12 is 18y. And then 25 plus 46 is 60 is 71. And we got our answer. I don't have to solve for x and y individually. I know that this is equal to 71. D is the winner. Boom, done. Number 7. The function f is given which table represents f of x minus 3. So again, we could leave it like this, and we could write it like this and put this into Desmos. What's the best way? Hold on. -6. Okay, another way that we could figure this out is just straight up think about it. All you're doing for f of x minus 3, watch, is x plus 6, x plus 5, x minus 4, and then f of x minus 3. We're just minusing 3 at the end. I know -6, -9 is wrong because if I plug in -6 to the original, it's going to zero this out, and we're going to get -3, not -9. So this one is out. We can do a little elimination. This might be the fastest. Again, you could plot it in Desmos and check the coordinates as well, but I think this is the best. Yeah, all of them have, okay, this one's wrong. We already confirmed -6 has to be with -3. Okay, let's try another one. -5 would also have to be -3. Oh, it's B. Because this one, they change, right? All of these are zeros. So again, you plug in -5, it would zero this out. We should get -3 again, which we don't, which means B is the only viable option. Boom, done. For the function Q, the value of Q decreases by 45% every time this goes up by 1. Okay. If you're talking about a decrease as an exponential, these are out because, look, that growth factor is bigger than 1 here. This is growth, not decrease. This is growth too because it's greater than 1. It's got to be this. So why? Now I just want to say, it says, let's check the other things. Q of 0 is equal to 14. Yes, plug in 0. Anything to 0 is 1, so you would get 14. And why is this a decrease of 45% when we see a 55 in there? Because it's 1 minus 0.45. That's how you get 55%. When you reduce by 45%, you retain 55%. That's why C is the winner. Done. Okay, we got to hustle here. A submersible device used for ocean research. Boom, boom, boom. Gives it at the surface. Okay, how many minutes after collecting the sample did it take for the submersible to reach the surface? What is the surface? 0, right? Because this is depth below the surface, so our surface is at 0. I'm just going to straight up use Desmos because this is a weird function. Check this out. Blop, blop. And we want to see when this is equal to 0. And, oh, I forgot a name. No, I did. Why is it going this way? Oh, yeah, it's going down. What am I saying? Gives the depth below the surface. Okay. Wait, this is weird. How does it come above the surface? Wait, what? Is the function f gives the depth below the surface of the ocean X minutes after collecting a sample. After this makes no sense. Hold on, did I write something wrong? X plus 19. What? I mean, I want to say it's 35, but how is this thing like flying? Yeah. Okay. Oh, I didn't even need to type it in. I forgot. It's just the x-intercept. I don't know. This question is bizarre to me, but it's got to be 35. We'll check the answers later, right? Let me know if you guys find that equally perplexing. How is the submarine gonna fly? Okay, cube has a length of 68 inches. Again, 68 inches, and again, as I mentioned before, we draw out any figure that's not given. So we have 68, 68, 68. It's a cube, so all the sides are equal. A solid sphere, that's like a ball, has a radius of 34 inches. Is inside the cube. Oh, that makes sense. It could fit, right? Because it'd be 34 or 34 like that. That touches the center and so it's perfectly inside there. To the nearest cubic inch, what's the volume of the space in the cube not taken up by the sphere? So it's literally this minus this. Now, they have the reference sheet. They have a sphere down here, right? So there's the volume of a sphere if you need it. But anyway, so we're going to do the volume of the cube, which is 68 cubed, minus the volume of the sphere, which was 4/3 pi r, which is 34 cubed. And that's it. Straight up Desmos problem. Let's check it out. 68 to the third minus 4/3 pi 34 cubed. And we get 150,000 approximately, which is this one. Boom, done. Number 11, what is the sum of the soluciones? Let's see. I wonder if we should plug this into Desmos. I have a feeling that each solution is going to be really weird, but let's see. Anyways, I'm going to do it as two separate equations. So the left side of the equation is 1, the right side is a second, and then we'll see where they intersect. 4x times x minus 7. Oh, this is kind of annoying. Yep, see, there's weird numbers. So instead, I'm going to use my little shortcut here. I'm going to show. I think this is going to be the better way to do it. We're going to distribute on the right-hand side x squared plus x minus 56 equals 4x squared minus 28x. We're going to get everything to one side. Minus x squared, we got 3x squared. Minus x, we got minus 29x. And then plus 56 is equal to 0. So the sum of the solutions, the shortcut is negative b, which is positive 29, over a. And that's it, 29 over 3. If we go back to our solution, or to our graph here, 29 over 3. The answer is 9.6 whatever, so 9 2/3, right? So here we have 2 2/3. So 2.666, we'll just do it real quick just to verify. And the other place where they intersect is at 7, right? Plus 7, and we get the same thing. Okay, I guess it wasn't that bad actually in Desmos. But anyways, those are two ways to do it. That's how you do it done. Which of the following tables are the values of x? Okay, so this is another inequality. I showed you how I do these before. Let's do it the same way again. Look for violations. Is 20 greater than 18 plus 2? No, it is not. Is 16 greater than 8? Absolutely not. If 20 is not, hey, what happened? Okay. What? Wait, these are all wrong. It's only D. So 24 is greater than 20. 36 is greater than 32. 48 is greater than 44. Yeah, so just straight plug and chug. That one was pretty easy to eliminate. That's it. 13. What is the diameter of the circle in the equation? Boo. So again, circle form. This is the radius squared. That means the radius is the square root of 16, which is 4, and the diameter is 2 times that, which is 8, right? They have the 4 there in case you forget to take that final step. But anyways, 8 is the winner done. In the given equation, C is the constant equation has one solution. All right, C is the okay. As soon as you hear number of solutions, I'm going to discriminant mode, okay? My discriminant is b squared minus 4ac. This is a, b, and c. So b squared is 30 squared minus 4. A is the in front of the x squared, which is negative 9. C is literally c. And if this has one solution, that means the discriminant is equal to 0. Two solutions, it's greater than 0. No solutions, no real solutions, is less than 0. Now we got an equation. Now we solve for c. 30 squared is 900. Negative 4 times negative 9 is 36. C is equal to 0. We're going to subtract 900 equals 36c. We're going to divide by 36. Divide by 36, I believe that's negative 25. But let me double check. Hold on. Negative 900 divided by 36 is negative 25. That's how you do it. Done. And then you could plot that if you want to and verify. But okay, here we go. Triangle, X, Y, Z. All right, so it's a right triangle. Hold on. Boop, boop, and boop. And Y is the right angle. Z is going to be 33. And X is going to be the complement of that, right? Because they all have to add up to 180. In a right triangle, the acute angles are complements, so that is 57. Okay, and then it says the length of YZ right here is 26. If the area and square units of triangle XYZ can be represented by yowzers. Okay, very interesting. So we've got this really cool thing. We know this side is 26. We know all the angles. And then it says the area. So what is the value of K? So this is a really interesting problem. So realistically, to get the area, it's whatever this length is, which is it's the base times height divided by 2. So it's 26A over 2, right? So that is my area. And then they're saying that the area can be expressed as K times tangent of 33, where K is some constant. Okay. So well, let's figure this out. What are they really doing when they're taking tangent of 33? It's tangent of this angle. So tangent of 33 is A over 26, right? So the question is, and by the way, 26, we can simplify this. 26 over 2 is 13A. So the question is, K, some constant times A over 26 has to equal 13A. So what is K? Well, now we have an equation. Now we can literally solve for K. So we go multiply both sides by 26 and then divide by A. Well, hold on, what's 13 times 26? 338. So we got 338A equals KA divided by A, and K is 338. That's pretty much it. There's lots of ways we can verify this, and if I wanted to, I would actually solve for A using trig, calculate the area, then plug in K and verify like that. Maybe I'll do that actually if I have time. This is the second module. I'm always so tight for time, so I want to be mindful of that. We can come back to it and verify. I'll show you what I mean. The regular price of a shirt in the store is $11.70. The sale, okay, so regular is $11.70. Sale price is, read this carefully, right? If you rush on this, you're going to miss it. The sale price is 80% less. That means it's 20% of. So the sale price is 20% of 11. Wait, what? Sale price of the shirt is 80% less than the regular price. Yep. And the sale price is also 30% greater. Oh, then we have the store's cost. Okay. Then we have the store's cost. And the cost, and then this is also 30% greater than the cost. Okay. So what is the store's cost? Okay, so watch this. I'm going to turn it into an equation. So I'm going to say the sale price, which we know what it is. It's this. The sale price is, meaning equal to, 30% greater, 30% more. That means we're multiplying it by 1.3. It's 30% more or greater than the cost. And now we have an equation, and now we can solve, okay? So we're going to just isolate in Desmos. So we got 0.2 times 1170. And then we got divided by 1.3. And there we go. We get $1.80. And that is it. Wait, do we enter this? Hold on. 20, so 2.2. I think we just entered as 1.8. I think it's going to give it to us. Disregard the dollar sign. Yeah, I think you can enter it as 1.8 or 1.80. I'll just leave it as 1. Let's do 180. Okay. Shouldn't matter. All right, we got 17 and we got 18 minutes left. I know that seems like a lot of time, but some of these problems can be crazy. ABC, blah, blah, blah. B and E each have a measure. Okay, so it sounds like these are similar triangles. So we're going to go boop, 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 boop. I'm just going to draw them of different sizes but similar proportions. So we got B and E are 27. And then C and F are 41. And then we've got A and D up top. I'll calculate them real quick. 68, that's 112, right? 112 plus 68 gives us to 180. Oops. Okay. And now, so which additional piece of information is congruent? Okay. Again, you got to remember the difference between similarity and congruence theorems. When we're talking about similarity, all we need are angles. We got angles, they are similar. Now to get congruence, since we know all the angles are congruent, we just need one side, because if I know that one side, corresponding side is the same, I have angle side angle to prove congruence. Okay, so let's see the options. So obviously angle measures are not going to help. We do need additional information. The length of AB alone is not enough, but B, C, and EF, that's what we need. And they are corresponding. So if I know that these two are equal, we're going to be able to determine if they're congruent. That's how you do it. Good old-fashioned geometry. Here we go. In the system of equations, R is a constant. The system has no solution. When you're talking about linear system of equations, and we know they're linear because everything is to the first power, right? We're talking about parallel. That's no solution. Same slope, different y-intercept. I don't even have to focus on the y-intercept for these problems. Just find what value is going to give me the same slope. So let's look at the top one. We're going to get into slope-intercept form very quickly. I'm going to add 72 to the other side. We have 102y is equal to 48x minus, I'm going to minus the 24 over. I'm doing this quickly because we're going to be running out of time potentially. So then we're going to divide everything by 102, divide by 102, divide by 102. And the key part is this. This is my slope. 48 over 102, which reduces to 24 over 51, divided by 3 is 8 over 17. Okay. So we know that the slope down here needs to be 8 over 17. That one is almost in slope-intercept form. Let's get it there by dividing by r. And I'm going to move the negative 16 in front. So we got negative 16 over rx plus 1 over 6r. Again, I don't care about the y-intercept. I just put it up there just to show you. But the key part is the slope. And again, they changed the order here, I think, to confuse you. But remember, slope is what is multiplying the x, not this thing. It's not based on the order, right? It's what's multiplying the x. So we need to figure out how to get this to equal this. So we'll set them equal to each other. 8 over 17 is equal to negative 16 over r. And now we can solve for r. So we're going to do a little cross multiplication. Use Desmos if you want. I'm going to do it mentally for fun. 8r equals negative 16 times 17. Actually, this part, well, whatever. I'll do it mentally. Let's see. 160 plus 70 plus 4 is 112, 160. So 272, right? Negative 272. And then we're going to divide by 8. Divide by 8. I think I can do that. That's 25 plus 9 is 34. I believe it's negative 34. But you know what? I'm going to double check because I did a lot of mental math there. All right, 1 second. 16 times 17 divided by 8. Yep, is negative 34. And that is it, I think. Let me double check one more time. Negative 34. Yeah, of course. So we got negative 34. That's how you do it. Which of the following expressions has a factor of this? Okay, let's see. X plus 2b. Boop, 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 boop. So we want to factor. Let me just look at all of these. And we got 3 and... Okay, let me do this. They all start with 3 and end with 14, right? So 14b, I should say. X plus 2b. That means if I were to factor it, I'd have to have a 3x here. And I have to have a 7 here because that's the only way I get a 14b at the end. Okay, wait, this is it, literally. And then we just FOIL this out and we got our answer. So check this out. 3x squared, 6xb plus 7x. Oh, wait. Hold on. This isn't going to work. 14b. And then, but we don't know what b is. Hold on. X plus 2b. And then 2b. So that means, okay, we can cross compare now. We can just be like, okay, I think this is still the correct expression. Let me see this for 1 second. So if b is 1, that would be 13 in the middle. No, b is 2, that would be 19 in the middle. If b is 3, that would be 18. Plus 7 is 25, 4, 24, 31, 5, 37, 6, 36 is 43, 7, 42, 7, 42. So it's this one. Okay, let me backtrack this a little bit. So basically what I did was I broke it up into what it would have to be, 3x plus 7, x plus 2b. And then I foiled it out and I got this. And I'm like, the only way, oh, and it says B is a positive integer. Okay, so then I ran through different integers to see which one would correctly match one of these. And none of those integers matched this until we got to 49, until we got to B is equal to 7. And then we actually get 49. There's no way to get any of these other middle terms. Okay, that's a weird one. Very interesting one, but that's how you do it. Okay, the perimeter of an equilateral triangle. So we got equilateral. All sides are equal. Boop, boop, boop. Is 624 centimeters. That means each side length is 624 divided by 3, which is 208. The height of this triangle is K rad 3. Hold on. Okay, this, if you're out of geometry for a while, this is a 30, 60, 90, because this is an equilateral triangle where all the angles are 60. So if I drop an altitude, which I did here, okay, to get the height, that becomes half of that 60, which is 30, 30, 60, 90. Now, which if you remember for 30, 60, 90, the hypotenuse is double the little side. So the little side here is going to be half of that, which is 104. And then the side opposite 60, the long leg is just the little leg times rad 3. And so that height, or that long leg, is 104 rad 3, which means K is 104. That's how you do it. Boom. 21. 2 data sets of 23 integers are summarized in the histograms. So the histograms, the first interval represents the frequency of integers greater than or equal to 10. Okay, so this is like here. Let me do this. So that would be like greater than or equal to 10. So that'd be like 10 and then less than 12. I've seen ones like this before. So right, it could be like 10 to 19. The next one is 20 to 29. Okay. The second interval for greater than or equal to 20, but less than, yeah. So what is the smallest spot? I've seen this exact question before. So I wonder if they just totally reuse it. But here's the thing, okay? I remember the answer. It's 1, but I'm going to explain why. So what they're doing is we want these to get as close as possible, right, to each other. So for this one, these are all slotted 1 back. These are 1 forward. So I want to make each one of these as big as possible. Like I want all these to be 19, and I want to make these each one as small as possible, because if I have 3 19s and 3 20s, that's pretty close, right? So what you notice is you're going to make all of these 20, 30, 40, 50, 20, 30, 40, and 50. And for B, you're going to make them as big as possible. 19, 29, 39, and 49, right? So you have 1, 2, 3, 4, 1, 2, 3, 4. And so when you then multiply them out, since they're all in equal distributions, you don't really have to do much. You see that since they're all off by 1, when you add them all up and divide, you're going to get a difference of 1. So anyways, that's why B is the winner. All right. We got 9:45 for the last problem. Let's see if we can knock it out here. I think they reused this problem from a previous test as well. The table shows a poll total of 803 voters selected at random were asked which candidate they would support for the upcoming election. According to the poll of 6424 vote in the election, by how many votes would Angel Cruz expect to win by? So it's not the number of votes, it's by how many votes. So check this out, right? Let's set up a proportion. So the number he's winning by in the poll is 163. So we're going to do margin of winning over the total. And you're going to see why this proportion makes sense, right? So 163 over what's the total, which is 803, right? And they give that as well, is equal to what's the real total? 6424. And we want to know the margin in the real thing. That's our unknown. We got a proportion. Now we can solve. You can even type this proportion in as is in Desmos. Let me show you. X over 6424. And then all you got to do is look at where the line manifests. And it's at 1304. And that's the margin. Yeah, or you could cross multiply and solve for X. Since we got a little time here, let's just have some fun with it. So we know that the margin would be 1304. Let's see what the actual values would be. So if I wanted to figure out actually like Terry Smith, I'd say like 320 out of total equals X out of that. So let's figure this out here. Let's just have some fun. So 320. So we'd get 2560. 2560 for Terry. For Angel, we'd get, hold on, 6424. Is 3864. And it looks like this makes a lot of sense, right? Because then what's our margin? It's 1304, just like we said. And those two add up to 6424. Okay. Anyways, that was pretty good. Let's go back to 15 just for fun. I think this one I said I wanted to show you guys that you can verify that this is correct. Let me find my work on this. Here it was, right? So I found that that constant was 338. So now let's go back to the right triangle. Let's actually solve for A. So the way we could do that, if you remember from trig, tangent of 33 is equal to opposite over 26, right? Opposite over adjacent. So that means this side here, if I multiply 26 over, it's 26 tangent of 33. So watch this. 26 tangent of 33. Make sure you're in degrees mode right there. And we get 16.88. So we get 16.88. So now you could do the area of this, which is this whole thing, 16.88 times 26 divided by 2. Boom. And we get the area of the triangle is 219.5. Okay. And then you could be like, all right, now let's go back to our original thing. They said k times tangent of 33 needs to give us this right value. So we said it was 338. Let's see if we get that area. Look at that. We get that exact area. Anyways, that's what I meant when I show you, when I was saying you could verify this with a little bit more work. But okay, we're going to go ahead and now if you were taking this for real, I would say use every bit of that last time to double check, triple check, quadruple check all of your work. But you know, we're just doing this for demonstration purposes. If I get something wrong, it's all good. I will check it. Here we go. All right. Let's let it load. We're going to check the test, make sure I didn't make any mistakes. Let's view our score here. I'm going to drop this down so you guys just don't see my login and all that. Here we go. We've got this. And we're logging into email. What? Why is this doing this? Wait a minute. No, it's not letting me log in. Hold on. Why is it it's not working? Come on. Hold on. I think I have to use some like email verification thing. Hold on. Yep. No, wait. Yeah, why can't I just... What is this? Verify to you with a security method. Yeah, let me put in my password. What? This is so weird. Hold on. There we go. Okay, it's signing in. Okay. Let's see. Practice. This PSAT practice. What? Hold on a second here. Where are my practice? Oh, here they are. Okay, got it. Boop-a-doop. That is the 8-1. All right, so it says that I got an 800, but let's still verify that I didn't make any mistakes here. Let's close this. Bloop-a-doo. Okay, so let's look at the math again. I left the English blank. That's why those are all down. These things are, I don't know. I feel like these are kind of meaningless because I've seen them be full and you still get things wrong. Let's just double check here. Correct. See, I got one wrong. So even though I got an 800, I still made a mistake somehow. That's so weird. How did I get something wrong? Okay, let's go back to number 12 here. I told you. If you guys were watching earlier, I somehow make mistakes on these questions. I don't get it. How am I making the... Oh, my God. I read it as greater than and not less than. I feel like my method is good on this where you just plug in values and check. But like I told you, routinely, these aren't obviously difficult problems. You can quickly use Desmos or something. But yeah, I don't know. I think I was going too fast because remember I was like 20. I think I said 20 is greater than 18. I read it as greater than, not less than. So I picked D, right? Because all those were greater. I don't know if anybody caught that. So I guess it's C. So yeah, 16 is less than 20. I mean, obviously it's C. 28 is less than 32. Oh my God. And then 40 is less than 44. Yeah. So just stupid mistake going too fast. And it is what it is. How funny is that? I called it and I still did it. So maybe that method will work for you. Maybe it's just not for me. So, all right, here we go. Let's get back into the mix here. Let's do another practice test. This time we're going to do practice test 9. We're not going to waste any time. And what's up, everybody? I see we got more people on the stream. If people would please give this stream a like, let people know what's going down, I would greatly appreciate it. We're going to be streaming for another 2 hours probably. It's a long stream, trying to get you guys ready and prepared for this SAT tomorrow so you can rock it out here. All right, let's check this out. Boom. Let's skip this. So again, I'm skipping the verbal. We are going to have zeros on the verbal. All good. Okay, boom. Let's skip this. Do. 3, 2, 1. Ladies and gentlemen, if you're new to the stream, just joining right now, we are going to do this test, practice test number 9 in real time for the first time, meaning I've never seen the test. I'm doing everything on the fly and to give you the real, true, authentic test-taking experience. You can see how I can think and react and respond in real time. I'm also going to try to give you a multitude of strategies to approach and attack each problem as we go through. And you'll see if I can do it in the time limit with the explanation, you can do this too. That's the idea. 3, 2, 1, let's go. All right, which expression is equivalent? Again, the parentheses are meaningless because it's a plus there, so I'm pretty much combining like terms. 2x cubed plus 2x squared plus x squared is 3x squared, so it's got to be either C or D. X plus 6x is 7x. We got them both there. Negative 9 plus 1 is negative 8. D is the winner. Boom, done. Number 2, John paid a total of $165. Making a down payment of $37 plus P monthly payments. So this is the number of monthly payments each. And this is a total of $165. So this equals $165. Which of the following equations represents the situation? See how I'm writing the equation as I'm reading to get my head around the facts. Happens to be that that's all they want. They want this equation. And it's right here in C. Obviously, the order is mixed up. Doesn't matter. Addition is commutative. That's how you do it. Boom, done. Make sure to misread this. Yeah, we're good. Number 3, the given equation relates positive numbers m, n, and p. Okay, so we want isolating quantities question immediately. M is isolated. Don't need to read anything else. Divide by 7 to isolate it. We've got 2 times n plus p over 7 for the win, which is A. Boom, done. Function g is defined by this. What is the value of g of 3? That is function notation. That means straight plug and chug. Now, you can put this into decimals and then in the next line type g of 3. I think it's faster just to plug in. 3 times 8 is 24 plus 1 is 25. Square root of 25 is 5. C is the winner. Boom, done. 20. And by the way, to get a square root in the Desmos calculator, just a little fun fact, you type SQRT and it pops up like so. Okay. Table gives the distribution of votes for a new school mascot for 80 students. If one of these students is selected at random, what is the probability of selecting a student whose vote for a new mascot was for a lion? Okay, wait. It's just straight up probability. There's no conditional probability here. So all we have to do is figure out how many people voted for a lion in totals. Right there, it's 20 out of the total, which is 80. So it's 20 out of 80, which reduces to 1/4. Boom, done. Okay, if this was a module 2 question, later question, it'd probably be conditional probability. You have to read it much more carefully, but that one's pretty chill. Oh, hold on, let me double. I'm second guessing myself. What did the student? Yeah, just one student is selected at random. Probability they voted for a line. 20 out of the total. Okay, sorry. 6, a student council group is selling school posters for a fundraiser. They use the function P of X equals this to profit for selling X schools in order to earn a profit. Okay, so this is straight plug and chug. Again, understanding the equation and the language. Plug in 900 for P and solve for X. Again, you can use Desmos. I will do this mentally just for fun. Add 220 over here. We got 1120 equals 5X. I got a little trick for dividing by 5, and the trick is, again, this is just for fun. You move the decimal over, and then you double the result. So it's 112 times 2, which is 224, and that is how you do it. Let's use Desmos just to be safe. 5 times 224 minus 220. It gives us that nice profit of 900. Double verified. Boom, done. 7, which of the following equations is the most appropriate linear model? So first of all, I see that I've got a negative slope. Positive slope for C and D. Goodbye, goodbye. I've got a positive y-intercept of 10, not negative. Goodbye. By elimination, B is the winner. Done. The solution to the given system of equations is blah, blah, blah. What is the value of y? Now, this is beautiful the way that they've given this to us, because I would not use Desmos for this. Me personally, it's way faster to just negate the bottom equation and combine these guys. Negative 3x minus 4 equals negative 2y. Add them together. Goodbye. 6 minus 4 is 2. 4 minus 2 is 2y. Divide by 2. Y equals 1. Just for fun, we can solve for x. Y would be 4 minus 6 is negative 2. So x is negative 2/3. But anyways, all they want is y. Y is 1. Boom, done. Let's just verify just for fun. Negative 2/3 is negative 2 plus 6 is 4 times 1. Yes. Negative 2/3 is negative 2 plus 4 is 2 equals 2 times 1. Double verified. Y is 1. Boom, done. Number 9. The frequency table summarizes 57 data values. What is the max in the data set? Now, frequency, this is where they're trying to get you, okay? I know some people might put 11 because you say, oh, 11 is the biggest number. Frequency is not the data set values. We want the max of the data values. This just means there's 11 of the 11s. But what's the max values? The highest data value, which is 14. There's 6 of them. 14 is the winner. Boom, done. Circle K has a radius of 4. Hold on, let's draw this out. Boop-a-doop-a-doop. K. And L has an area of 100 pi. Again, areas pi are squared, so I know that L has a radius that's the square root of 100, which is 10. What is the total area of the two together? Okay, so we know that this one is 100 pi. We know that this one is pi r squared, which is 16 pi. So we add them together, we get 116. Boom, done. By the way, this actually, wait, what? This makes no sense. It has to be D is the only viable option because it's the only one greater than 100 because and then they're asking what is the total of the two together. It's got to be that. Yeah. This one, what is the value of 4 minus 3x? Now, this one's a very interesting one. A lot of you guys might plug this into Desmos, solve for x, and then plug it back into this. No. There's a layup here. If you treat this as a single variable, all I have to do is minus 8 times 4 minus 3x. Keep that together. So 9 times this minus 8 times this is 1 times this. So now I've got, I moved that over. I subtracted it. I've got this plus 2 is equal to 18. Last but not least, subtract 2. And I get this quantity is equal to 16. That's great because that's what they were asking for. 16 is the winner. Now, again, plug it into Desmos. You could just solve for x, then plug that value into the expression, and that's fine. But I'm just saying that's the easiest and fastest way to do it. Number 12. Similar triangles again. Are these right triangle? Yeah, they are right triangles. Okay. So we got boop, boop, boop. Wait, no, it's too small. Boop, boop, boop. And we got boop, boop, boop. I like to draw them different sizes so that it reminds my brain these are similar, not congruent. And G and K are right angles. F corresponds to J. And so then obviously H corresponds to L. Okay. F, G, H, J, K, L. And here's the thing, okay? If they're similar, right? Sine, cosine, and tangent of the same angles in different triangles, right? It's the same. Because it's all about the proportions. If these triangles are similar, they are proportionate. Again, sine of F is the proportion of opposite over hypotenuse. It's going to be the same for J. So they want sine of J, which is the corresponding angle. It's again going to be 308 over 17. That's how you do it. Boom, done. A wire, I'm losing my voice here. Wire with length of 106 is cut into 2 parts. Boop, boop. One part has a length of x inches. The other part has a length of y inches. And we know x plus y is equal to 106. The value of x is, watch how I'm turning this into an equation, 6 more than 4 times y. What is the value of x? Look what we have, a system of equaciones, and all we have to do now is solve for x. So I'll do this by hand just for fun. We'll do a little substitution. I'm going to say y is equal to, what is that, 106 minus x, right? If I subtract x from both sides, we're going to plug this in for y because we're solving for x. Again, you can plug this into Desmos if you want, but I'm going to do it this way. 6 plus 4 times 106 minus x. Actually, you know what? I'm going to do it in Desmos. This is annoying. Okay, so then we've got x is equal to... Actually, no, let's just do the straight-up equations. So at the beginning, we had x plus y equals 106, and then the other one was x equals 6 plus 4y. And we're looking for the intersection of the two lines and the x value in particular, which is 86. That's how you do it. Boom, done. A certain township consists of a 5-hectare industrial park and a, 24-hectare neighborhood. So 5, 24. And the total number of trees. So this is trees in the population. So that means that X is the number of trees per hectare here. And Y is the number of trees per hectare in the neighborhood, right? Because we're getting total. If we got trees over here, we need total trees and total trees in each piece, okay? And, okay, which of the following is the best interpretation of X? I already said it. It's the number of trees per hectare in the industrial park. Done. A, right there. I didn't read the answer choices. I tried to figure it out in my brain first from the equation, and then I just match it. It's not neighborhood because that's 24. I'm just going to double check. It's not total number. No, it's not the total number of trees. This is the next best option. C, the answer would be correct if they said, what is the interpretation of 5x? No, they just wanted x. Which expression is equivalent to this? All right, this is just turning a rational back into radical format. So it's a to the 11th, and we're taking the 12th root. That's what it is, right? The bottom number is the root. The top number is the power. And what? They don't have it. Wait, what's happening here? 11. This is weird. Hold on a second. Am I crazy? The a to the 11, and then the 12th root of that. Oh, I see what they did. This is so bad. It's B. I'll tell you why. This is crazy that they did this. So I'm trying to think about how to convert this here. Okay. Watch this. The reason why B is correct, I can work it backwards, and I'll show you how you can get there. The reason why A is correct is because B is correct is if you convert this back into the fractional exponent is 132 over 144. And then you can just treat it like a regular fraction. You can divide the top and bottom by 12, and then you get back to 11 over 12. So that's working it in reverse. But if we come back to this and we're like, we see that, this isn't there. What they did was they multiplied by 12 over 12, which is allowed, right? And then you get 132 over 144, and then it translates to this. But that's an interesting one. Okay. 16. The function f is defined by this, an xy plane, the graph fx translating the graph up by 4. So we saw another one like this earlier. So I'm going to say they're going to put something like this on the test tomorrow because it's kind of a new one, and they're doing it twice. So when you shift it up by 4, it's like this, okay? And then they say, what is the value of g of 0? So literally, you can put this into Desmos and plug in 0. I'm actually going to do that. Watch. So actually, I'm going to show you a really cool way to do this whole thing. So it makes a lot of sense. So we say this, and this, okay? So there's the f of x. They said g of x is translating f of x up by 4. So now we've got our g of x function, right? Which is and you can double check, right? Did it go up by 4? There was 40.3. Now it's 30. It's not clicking. 36. Yep. So it went up by 4. So goodbye. And then now they want g of 0. So literally you can just type in g of 0, and we got our answer 76. Yeah. Okay. Again, if you plug in 0 here, you get 6 times 2 is 12, positive, and then, or negative, which makes it positive, times 6 is 72, plus 4 is 76. Double verified, done. The solution, hold on, to the given system is xy. What is the value of x minus y? Okay. I'm trying to think if there's a layup here. X minus y. If I negate that, that's 3, 7, 3, 4. 12 is 3, 4 is 16. Nah. I think I'm just going to plug it into Desmos and see if we can get nice values for those two. Y equals 4x plus 1. 4y equals 15x minus 8. Oh, they're parallel. Oh, no, they're not parallel. That would be impossible. Hold on. There we go. So we got X equals negative 12, Y equals negative 47. So we got negative 12 minus negative 47. That's a plus, and it's 35, I believe. Yep, baller. And there's our answer, 35. Boom, done. Okay, a few questions left. Here we go. The given function F miles number of coupons sent to the customer at the end of the year. And T is the number of years since 1998. So we're going from 1998 to 2003, right? Because it's from 0 to 5. Which of the following is the best interpretation of the y-intercept of the graph of this context? Okay, so y-intercept is going to occur when t or x or whatever, the input value is 0. You plug in 0 and you get 8,000. So we, again, t is 0, that's 1998. So that means we get 8,000 coupons in 1998. The minimum estimated number of coupons the company set to. I mean, it's not the minimum. Oh, well, I guess it would be. No, it's not going to be because this is going to go down. This is depreciating, so it's not the minimum. It's this one, what we said at the beginning. The estimated number of coupons sent at the end of 1998 was 8,000. Yeah. That is it, ladies and gentlemen. Number 19, a landscaper uses a hose that puts, here, let's write this out, 88x ounces of water into a bucket in 5 y minutes, okay? Which expression represents the number of ounces of water in the hose, the hose puts in the bucket in 9 y minutes. Okay, that is a great proportion problem, okay? So minutes, ounces. So in 5y, we're putting in 88x. So then in 9y, I want to know what we're doing here. Now I'm going to call that unknown c. Usually I call it x, but we already got x in the mix, so we can't do that. And literally, all I need to do is solve this proportion. So here we go. Cross multiply 5yc is equal to 9 times 8, 720 plus 72 is 792, right? 792xy. And then we're going to be dividing by 5y to isolate c. 5y to isolate c. Bop. Cancel out the y's, and we get 792x over 5, which is D. Boom. Legend. Next. Number 20. What is the small soluciones to this one? Should I just plug it into Desmos, I feel like? Let's just plug it into Desmos. Okay, so what I'm going to do, what I like to do with these equations, instead of just typing in the equation as is, I type in each one separately. I like it better in terms of being able to find the solution. It's personal preference. But I say one equation is the left side. You don't even need the y, but one equation is the right-hand side. And we now have these two great functions. And the solution is going to be when these two intersect, right? So we've got, and we're looking for the x values. So we got negative 3 and 10. And so negative 3 is the smaller of the two. Boom. We can plug it in just for fun and verify. Negative 3 minus 2 is negative 5. Square root is 25. Square root of that is 5. Negative 3 times 3 is negative 9 plus 34 is 25. Square root of 25 is 5. Double verified. Done. All right. We got another similar triangles. Let's see. Are they right? No, they are not right. Okay. Bop, bop, bop. Bop, bop, bop. And we've got, let me make them bigger so we know they're not the same. X, Y, Z, R, S, T. Again, they said similar, so all the corresponding angles are congruent. And when they say it X, Y, Z similar to R, S, T, that means X and R correspond, Y and S correspond, Z and T correspond. That's why I did it in the same order, X, Y, Z, R, S, T. Then it says the measure of Z is 20. I know it's not drawn to scale, but that means the corresponding angle T is 20. And that's all they're asking. What is T? It's 20. Does this matter? No. The proportion of the sides have no impact on the proportion of the angles. The angles are going to be the same. But, you know, if 2xy, right, if double this one is equal to this one, yeah, if they were asking for ST and we knew YZ, I'd double it. But they're not asking about that. They're asking about an angle. 22, the function f is defined by this, which the following equations defines g. Let's see. Hold on. All right. So, again, x plus 2, I mean, literally, you can just plug this in. 9, 4 to the x plus 2. That's it. Now, of course, they don't have that option here, so you got to figure out how they did this. Now, one thing you could do is, since we know this is correct, you could plug this into Desmos, plug these in, see which one matches. I'm fine with that. A little bit easier, or not easier, maybe a little faster, is recognizing the College Board's tricks. What they're doing is they want you to use the exponent rules. When the exponents are being added, it's like two of the same bases with those values being multiplied. So this is the same as 9 times 4 to the x times 4 squared. 4 squared is 16. Bring it out front. 16 times 9 is 144. And that's the equivalent form that they want you to determine, which is B. That's how you do it. Okay. I'm just going to take a second sip here. Let me take some water. Okay. Oi. 3, 2, 1. Let's go. Mod 2. What is the median? You can literally type this into your calculator, but it's easier if you just look at it and see, all right, it's ordered from least to greatest, which is nice. I need the middle. Median is middle. 4 here, 4 here. My middle is 79. If it was an even number, you take the average of the two middle, but we don't need to do that. 79 for the win. Boom, done. Right triangles L, M, N, and P. Okay, so they're right. So boop. Well, let's go this way. I like to go this way. Boop and boop, boop, boop. L and M, P and Q. Again, that's the same order, right? L and M, P and Q. Angle M has 53. That means the corresponding angle Q is also 53. And that means L doesn't say which ones are right. Wait, this is weird. Oh, what am I saying? It's just asking for Q. We're already done. Again, filling in that little basic information is going to be helpful. Similar triangles, corresponding angles are congruent. Boom, done. Table shows the value of X and the corresponding values of Y. For this, in the table, A is a constant. What is the value of A? Well, this is straight plug and chug, right? Y equals 4 times 2. Instead of X, we're plugging in 3, right? That's the X value, reading the table. And then A is the corresponding Y value. 2 cubed is 8 times 4 is 32, plus 3 is 35. B is the winner. Done. How many solutions does the given equation have? Infinite, because these are the same. I can plug in 1, 2, 3, 4, 0, a million, a trillion. It's all going to work. Boom, done. A model predicts the population Bergen in 15,000 was 15,000 in 2005. Okay, I'm going to write some coordinates out because, okay, look. Notice they say X is the number of years after 2005. So when X is 0, that is 2005, and that gives me this coordinate, right? And then it says it increases by 4% each year. So in a exponential equation, I already know my initial value goes in the front, the 15,000. The amount I'm increasing by, that growth rate, is 1.04 because it's growing by 4% and then to the X. And that's all they want. They want the equation that models this. It's right there. I did it. D is the winner. Boom, done. Number 6. This is the function. The xy plane is x-intercept of a 0. So the x-intercept is when y is equal to 0. Y-intercept is when x is equal to 0. But we see this in slope-intercept form. So I already know my b is 28, right? That's my y-intercept. To get my x-intercept, I plug in 0 for that and solve for x. So 0 equals. You could also graph this and find them pretty quickly, actually. Desmos might be an optimal option here, to be honest. Subtract 28, divide by 4. X is equal to -7. So that means A is -7. Adding the two together, we get 21. Just so you can see. You can plot it like this, and you get your x-intercept, your y-intercept. This is faster. So I should have done it in Desmos, but that's how it goes. Boom, done. Which expression is equivalent to this? All right, immediately I'm recognizing I should factor this. So the denominator, I mean, x minus 7 minus 3 times x minus 7 over 2 times x minus 7. Look at that. That means I can divide by x minus 7 and be like, goodbye. Wait, hold on. I can be like, divide, divide, divide. Those all go to 1. So now I have 8x minus 3 over 2. We've simplified it to B for the win. Done. Number 8. Circle A has a radius of 3n, and circle B has a radius of, it's way bigger. Hold on. Let me shrink this down a little bit. We're going to do this little copy and paste here just to save time. Circle B has a radius of 129n. The area of B is how many times the area of A? So There is a really great way to do this. But and I'm going to show you both ways. First and foremost, you just calculate the area of each of these, right? Pi r squared, that's A. Pi r radius squared, that's B. And then if you want to know how many times you take this quantity and divide it by this quantity, the ends will cancel out, so it doesn't matter. Okay, that's one way. The other way is to recognize the ratio of the radii, the side lengths, right? So it's 3 to 129. This is divisible by 3. I believe it's 43, right? So it's a 1 to 43 ratio for the radii. Since that is a measure of length, the area ratio is going to be the same ratio except squared. Okay? So I have a 1 to 43 squared ratio, which means that the second one is going to be 43 squared times the area of the first, which has got to be this. This is the only one that makes sense. Anyways, that's how you do it. Excuse me. Circle O. I'm losing my voice. Oh my God. It has center O. And no, I'm going to do a better circle than this. Hold on. Circle O. And then we've got R and S line the circle. Boop-a-doop-a-doo. ORS has in triangle ORS, the measure ROS is 88. So we're going to draw in this way and this way. Okay. And now we know that this is the central angle is 88 degrees. What is the measure of R? Okay. So what they're talking about, if I draw this triangle across, oh, sorry, it's triangle ORS. So they're talking about RSO. This is my unknown. Okay. So remember, triangle inscribed in a circle is going to be, what's it called? Isosceles. Oh my God, I'm blanking. And so because these two are radii already are equal, that means these two angles are equal, which means this plus, basically we know it all adds up to 180. So I can subtract 180, this from 180, which is 92, right? And then divide it by 2, because each one of these has to be the same. Each one of these are 46, 46, 46 for the win. Boom, done. 10. A business owner plans to purchase, okay. Business owner plans to purchase a model of a chair for each of 81 employees. The total budget to spend on these chairs is $14,000. Which includes a 7% sales tax. All right. Okay. So we need to make an equation. So what we're doing is we're buying 81 chairs. We don't know. We need to know the cost of the chairs. So we're doing 81x. And then on top of that, we have a 7% sales tax. So whatever this total is, we're adding on 7%. Now I've got an equation to represent this problem. That's the number one thing. And what are we solving for? We're solving for the cost per chair before taxes, which is exactly X. All I got to do is simplify it by dividing by 1.07 times 81. Done. So the equation reigns supreme. 1.07 times 81. And we got our answer, 161.53. That's how you do it. Boom, done. Number 11, a right triangle. Hold on. A right triangle has legs. Let's draw it out. Of 24 and 21. The length of the hypotenuse is 3 rad d. What is the value of d? Okay, this is Pythagorean theorem, right? So we have 21 squared plus 24 squared equals 3 rad d squared. Pythagorean theorem, that's the hypotenuse. That's how we do it. Now we just solve for d. Okay, I'll use a little help here. I think I know 24 is 576 when you square it. I can't remember. Okay, 576, 21, 441 I want to guess. 441? 441, okay. 441 plus 576 equals 3 squared is 9. Rad d squared is d. Look at this nice equation. Now, we've got 441 plus 576, which is 1,017. And then to isolate, we divide by 9, and we get 113 for the win. Boom, done. Again, get an equation, isolate. The positive number A, watch this. Immediately, I'm seeing an equation. So I'm going to make it into an equation. A is, that's my equal sign, 230%, turn it to a decimal, 2.3 of B, that means multiply by B. And A is 60% of C. If C is P% of B, if C is P% of B, which is the following is close to P. Okay. So we got a nice little system of equations. Now you could say, all right, let's, substitute and do all this and blah, blah, blah. Guess what's going to be the easiest? Picking numbers. Excuse me. So I'm going to say that let's call C, what should be the easiest? Okay, let's do it like this. Let's make B 100. Then A is 230% of B, which means, 2.3 times 100. A is 230. And then C would be 60%. I'm sorry, 60% of C is 230. So divide 230 by 0.6. Hope we got nice, easy numbers here. Divided by 0.6. No. Got bad numbers. Okay, well, it is what it is. It'll still work. I was hoping we didn't have to write like this weird stuff. Anyways, and now what we got to do is plug and chug into this equation. So we got 383.3 repeating, annoying. Okay, is equal to P over 100 times B, which is 100. Oh, wow, this is so nice. Actually, this is pretty straightforward. Cancel, and we get P equals 383.3 repeating. It's D. Done. 13. Here we go. For x is greater than 0, the function f is defined by the following. Okay, f of x is equal to 201%. Convert that to a decimal, 2.01 of x. Which of the following describes this function? Well, look at the function. I know you want to say percent usually indicates exponential, but that is not an exponential function. That is a constant multiplying x. That is linear, increasing because this is positive. That's how you do it. Done. They're trying to trick you there. The table gives the coordinates of 2 points in a xy plane. There's a line. The y-intercept is, okay. Y-intercept occurs when x is equal to 0. That means k minus 5 is 0. That means k is 5. Okay? So I'm going to use that information to rewrite these coordinates. 5, 13. 5 plus 7 is 12, negative 15. I already got 2 points for this. Now, this is amazing. Now, what are they asking for? They're asking us to find the y-intercept. If I got 2 coordinates, I can create an equation of the line very easily. I'm going to calculate the slope and then plug and chug, right? 13 minus negative 15 is 28 over 5 minus 12, which is negative 7. My slope is negative 4. I think I've seen this problem before. I think they did this one before. Then let's use point slope. Y minus, let's choose either one. Let's say the top one, 13 is equal to negative 4 times x minus 5, okay? And let's isolate. Let's get into slope-intercept form. Y equals, distribute, negative 4x, negative 4 times negative 5 is 20, plus 13 is 33. What's my y-intercept? 33. Another way you could do this is as soon as we get our coordinates, one of my students showed this to me. Shout out to my student. You can also be like, hey, let's make a table, okay? We got 2 points. We've got 5, 13. We've got 12, negative, 15. And then we do this little nifty thing. Linear regression, and there's my equation. Negative 4x plus 33, y-intercept is 33, boom, done. You might like that better. 15. We got 22 minutes. We got to hustle. Keenan made 32 cups of vegetable broth. Keenan filled x small jars and y large jars with broth. Equation 3x plus 5y equals 32. What is the best interpretation of 5y? Okay. Now notice, I've seen this question too. So I think I've reviewed some of these with one of my students. So that's why I have seen this one, and I remember it. But anyways, total cups of vegetable broth right here. And we have 3x, 5y, right? So this is going to be the total cups in the small, total cups in the large. So that's what 5y is. It's the total number of vegetable cups of broth in the large jar. I think since it's y and y is large, it's either A or C, right? Now, if it was the number of large jars, that would be straight up y. Because they already said that. Y is the number of large jars. So it can't be A. Therefore, by default, it has to be C. I hope that makes sense. These problems can definitely be tricky. 16. One of the two equations is a linear equation. The system has no solution. Okay. No solution. We talked about this. It's when we have a parallel, right? So I need to know what's going to be parallel with this, meaning I need to calculate the slope of this. Let's put it in slope-intercept form quickly. 3x plus 45 divided by 36. Y equals 3 over 36, which is 1/12. X plus, just for fun, I'll do this, but we don't care about the y-intercept. Then the reason why I say that is, yes, parallel lines have different y-intercepts, but they're not going to give you a question where, actually, wait, that's not true. They could give you, actually, no, they could give you a line that's what's it called? That is equivalent. Never mind. I changed my mind. And in a lot of ways, when you're trying to solve for a particular constant, to make the lines parallel. I guess what I was trying to say there, it doesn't matter. That can be a case, but let's just keep going because we do need the y-intercept here because one of them might be same slope, but also same y-intercept, which would not be no solution. So 45 over 36 divided by 9 is 5 over 4. So this is the equation of the line. We need slope of 1/12, but we need a different y-intercept. So let's see. Here we would get a slope of 1/12, but we would get the same y-intercept. See, this is exactly it. This one is not going to work. And then alternatively, if I divide by 4, this one's going to work. And because if I divide by 4, I get 1/12 x equals y. And then this is 1/12 x plus 5/4. So they'd have this would be a y-intercept of 0. This would be not a y-intercept of 0. So they'll be parallel. I'll show you just for fun. So now let's close this out. 3x minus or 3x equals 36y minus 45. And then we've got, what did I say? We're going to put it in verbatim. 1/3 x equals 4y. 1/3 x equals 4y. And you can see they're parallel, and that's how you do it. Okay, by the way, guys, if you guys are putting comments in the chat, I will get to them as soon as I'm done with this test and I look at the score, and then we'll get on to practice test number 10. Which of the following are solutions to a given equation where a is a constant and a is greater than 30? Okay, so look at this. Yeah, I've seen this type of problem before too. 29 is going to work, okay, because we get 0 equals 0. So 29 is definitely legit. So we know that 3 is works. So that one's out. Okay, so it's one of the, now it's either a or a plus 1, right? Here's the dealio. If I plug in a as x, I get a minus a is 0. And then I'd get x, and then 0 times that is 0, and I get 0 is equal to a minus 29. And it already said, so if a was 29, these will be equal, but it says a is greater than 30. That means that a didn't work. So 1 is a failure. So goodbye and goodbye. So it has to be C. But let me show you why 2 works, okay? And you can just plug this in. Plug in a plus 1 for x. So we get a plus 1 minus 29. On the other side, and that becomes a minus 28. On the other side, we get a plus 1 in for x minus a times a plus 1 minus 29. So what happens here? Those cancel out. We get 1. That's 1 times anything is itself. A plus 1 minus 29 is a minus 28. They are equal. It works. Boom, done. 18. 1 gallon of stain. Oh, okay. 1 gallon of stain will cover 170 square feet, right? Which equation, and a yard has a total fence area of W square feet. Which equation represents the total amount of stain needed to stain the fence in this yard twice? Okay. So here's the dealio, right? And you could even plug in values for this. Actually, let's plug it in, right? Let's say W is equal to 170. I'm sorry. Let's say W is 340. Okay. I'm choosing that because then I need to stain it twice. And so if 1 gallon does 170, I'll need 2 gallons. Okay. So when W equals 340, S needs to equal 2. S needs to equal 2. So let's plug it into all of these. So W is 340. S needs to equal 2. Let's see for which these. We might get 2 that work, but we're definitely going to get multiple that don't work, and we can eliminate those. So when S equals 2, definitely doesn't work here, right? 170 times 340 is out. 2 equals 340 times 340 makes no sense. And then we have 340 divided by 85 is 4, not 2. Look at that. Just with that nice little example, getting our mind around the problem, choosing nice constants to plug in, we got it. It's A. Done. 19. The xy plane, we got this equation. This intersects y equals c at exactly 1 point. Okay. What is the value of c? First of all, y equals c is going to be a horizontal line. If it intersects at 1 point, by the way, this is a parabola going like this. To intersect at 1 point, here it's intersecting 2, 2, 2 until bop right there. Meaning I need my line to hit the vertex. Okay. So let's be economical here. Let's just straight up use Desmos. Let's find that vertex, the y value of the vertex, and then we're pretty much good to go. Plus 9x. I'm really losing my voice here. 1 second. It's a long time to stream for 3 hours. So there it is, right? There's my vertex. And so then I need y is equal to that value. Negative, what was it, 79.25 or something? Hold on. I think I messed it up. Oh, sorry. 79.75, excuse me. And there it is. We got our answer. C is negative 70. Oh, come on, dog. And then they put it as a fraction. But watch this. Look at this little nifty trick in Desmos. Click this little button. Boom. We got them. What? Did they just... Oh, there it is. Negative 319 over 4. C is the winner. Boom, done. Now, we've got the quadratic function G. We have 3 questions left. 15 minutes. We should be okay. Models the G miles the depth, the meters below the surface of water, C, T minutes after depth. Okay, so it's quadratic. I guess either like this or like this. Okay. It reaches its maximum depth of 302.4 at 6 minutes. So this is my vertex, okay? And I guess it's going to be... Yeah, it's going to be like this, and because it said the max value, and I guess even though depth we think negative, right? I guess... Oh, I just thought back to that weird submarine problem. Maybe it was measuring like the positive values were depth, so it wasn't... Okay, anyways, I just remembered that. That's funny, because I was very confused by the modeling. So then, and then it says it reached the surface 12 minutes after. So 12 is one of the x-intercepts. By the way, that means the other x-intercept is 0, 0. Okay? What is the estimated... So this isn't... You know what we're going to do? We're going to do this straight up in Desmos with the modeling. Watch this. Table. So we have 6302.4. We've got 12, 0. So that's 2 values. We need a third value, but we have one. As I mentioned, we know the other x-intercept is 0, 0. So you might say, how do I know that? Because the x-intercepts are equidistant from the vertex. So it's 6 that way, 6 that way. So then I have 0, 0. You're going to like this little trick. Now we're going to say regression, but not linear, quadratic. Look at that. That's amazing, right? We get our nice parabola, and let's verify that there's our max. Boom. And now all we got to do is see when is this going to equal 10, right? I mean, what is the function value when x equals 10? Here, let's plug it in correctly again. What do we have? Negative 8.4. And then we have 100.8x. And then we have 0. Okay, so just make sure it overlaps. Yep, and then now we want f of 10. And that's it. We got 168. So let me just make sure I didn't make a mistake. Depth to nearest 10 minutes. So it's hitting that at 0. I feel like that makes sense. Let me make sure I didn't type that in wrong. Yeah, that makes sense. Okay. That's how you do it. Done. All right, 21. Excuse me. The area of a rectangle region is increasing at a rate. So let's draw a rectangle. It's 250 square feet per hour. Cool. Which is defining as close to the rate in square meters per minute. Oh, this is straight conversions. Okay. So we got 250, what was it? Feet squared per hour. And we want it in square meters. Okay, per minute. So first let's convert it to minutes. That's pretty easy. Again, as I mentioned, the unit on the bottom, we need to flip-flop it if we want to convert it. So hour on top then. And how many minutes in an hour? 60. Cancel, cancel. So now we got it into minutes. Now I need feet squared to meters squared. The problem is they gave us the length conversion. So as I mentioned before, if we know the length conversion, where we're going feet to meters, I take the feet value, 3.28. I take the meter value, 1, and I just square each of them. That's it. And now we got what we need to do to simplify this. So let's multiply it out. On top, we just got 1 and 1, so that's chill. And on the bottom, hold on. Let's just close this stuff here. Come on, get rid of all this. Okay, so then we got 250 times 1 times 1. On the bottom, we got 1 times 60 times 3.28 squared. I almost forgot the squared. And we got 0.39. A is the winner. Done. Let's just now think about this for a second. That would be, let's say 8 times 30, right? Let's say 9 times 30, easier. 9 times 30 would be like 3 times 10. Wait, that feels so small. Hold on. Oh, but then per minute. So 3 times 10, it'd be 30 square meters. I'm just doing it mentally to double check myself. 30 square meters per hour. And then you divide by 60. So it's about a half. So 0.39. So that feels good. Okay, sorry. I was just doing some mental calculations to verify. We got 10 minutes for the last problem. We should be good. Given a pair of equations, A and B are constant graphs of this pair of equations. It's a pair of perpendicular lines, which means slopes are opposite reciprocal. Straight up. Okay. So we can use this to solve for A and B, right? 7y is equal. So immediately I'm going to put it into slope-intercept form. Divide by 7, negative 5 over 7x plus 1 over 7. I don't really care about the y-intercepts. They're perpendicular. The slopes are opposite reciprocal. So A and B have to give us a slope of 7/5 in the bottom. Let's isolate the bottom one. by is equal to negative ax plus 1. Again, putting it in the slope-intercept form, y is equal to negative a over bx plus 1 over b. So that means negative a over b has to equal positive 7 over 5. And hold on a second. Okay. So we can get 7b is equal to negative 5a. So we can get b in terms of a. What's the best way to do this here? To actually choose values. A is negative 7. I want to choose, I almost want to say that A and B should be, like A should be negative 7, B should be 5. But the problem is it could be anything in that ratio. It shouldn't matter. It shouldn't matter. Yeah, we should be able to figure this out by choosing values. So I'm just trying to think in real time what's the easiest thing. I'm going to say A is negative 7, B is 5. And that would work, right? Because, again, we get positive 7 over 5, and that would give us the perpendicular slope. So if we choose these values and then run through these, we should be able to figure this out pretty quickly. So I'm going to just expedite this, and then we're going to verify in Desmos. So the slope of this one, if we move it over, is negative 10 over 7. So for this one to be perpendicular, the bottom one should be 7 over 10, right? If we minus ax and then divide by negative 2b, right? For this, we'd get 7 over negative 10. And that's incorrect because we need these to be opposite reciprocal. So I need positive 7/10, not negative 7/10. So that's out. Next, this is going to be negative. Oh, it's going to be this one. It's going to be B. Look. Because, again, when we isolate, it's going to be negative 10 over 7. For this one, we isolate, it's going to be negative A, again, over positive 2B. Plugging in our values, we know that A is negative 7. So negative 7 is positive 7. 2 times B is 2 times 5 is 10. And they're perpendicular. Okay, now we're going to verify in Desmos just for fun. So we got, let's see here. We've got 10x plus 7y equals 1. And then the second one was ax plus 2by equals 1. Ax plus 2by. Okay, and the way we're going to... Okay, let me think about this for a second because... I know we set specific values, but we said that 7b equals... Here, watch this. As long as 7b equals negative 5a, right? So if I choose any value that matches that proportion, we're going to be good. So if a equals 7, b would equal negative 5. And they're perpendicular. See that perfect perpendicular? I mean, it's a little hard to tell just straight up from the graph. Parallel is much easier, but anyways. And then what did I say the other option was? If this is negative, this is positive. It works again, perpendicular. Another option would be negative 14, 70, and then B would be positive 10, and it works. So in every case, it works. So anyways, I did it with a specific example. I was just showing you that generally that's legit. And we're going to end. I know we got 5 minutes left. If you were doing this, you would obviously check all your answers twice, 3 times, 4 times, as many times as you can. You do not stop tomorrow on the SAT. But just to show you, we're just going to end it. If I got something wrong, no big deal. We will check it and correct it. Okay, it's logging me back in here. I'm just going to push it down until I log in and I sign in. Boop, 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 boop. All right. Just logging back. The College Board account, it always logs me out. By the way, guys, if you are watching right now, please give this video a like. That would really help with the algorithm and all that good stuff. I would really appreciate it. Okay, I think I got it here. Oh, I got a 790, so I must have made a mistake. How is this possible? How am I making mistakes here? Okay, let's take a look at the math that I got wrong, and maybe you guys caught it as we were going. Yeah, I got one incorrect, so let's see here. I'm guessing somewhere in mod 2. What? Oh, there it is. Number 18, so let's review this one. Bro, I got this one wrong. How did I get this one wrong? What? Have I lost my mind? If W has 340. Wait a minute. Oh, it did work. Oh my God. I just realized something. I just totally misinterpreted this. So I was so wrong when I read it before. So remember I said that 340 square feet would require 2 gallons. That was so wrong. That would be for 1 coat. I rushed that one. That was a mistake. So instead, you said we need 2 coats, right? So if 170 only requires, that thing covers 170, then 170 for 2 quotes, two coats, not quotes, would require 2 gallons, right? So when I plug in if I plugged in 340, I shouldn't have even used 340. I should have just used 170. Should have given me 2. So if I plug in 170 here, I get 1. That's incorrect. And obviously those 2 are wrong. 170 divided by 85 gives me 2. For 340, we should have needed 4 gallons. That's why D was correct. Now we go to the chat. I want to see if anybody caught that. People aren't. Hey, Cole, what's up? What's up, dude? Okay. Anyways, that was a crazy mistake. I apologize for that, guys. I don't even know how I can't believe I did that. But that would be one of the ones that you would go back in and make sure to catch if you were taking this for real. All right. Oops, I already hit view score. Okay, done. Let's return to home. We got 1 left, and we're going to try and do it in under an hour. Here we go. Full-length practice. We are going to test number 10. Guys, tell your friends we're going to be live for 1 more hour if they want to jump on and check this out. We're doing practice test 10 in real time for the first time. That's how we do it. I feel like this is the best test-taking experience that you can get to watch me do it. Think, contemplate, get stuck, make mistakes, learn from my mistakes, all that good stuff. And I will teach you a multitude of ways to do the problems within the time limit as best I can. I started doing these live streams long ago under time conditions because I would always get the questions otherwise. Well, like, yeah, you're telling me you can do this and that and the other, but under time constraints, I can't do it this way. It's not going to work. And I wanted to show people, well, yes, you can. It does work. And not only, I feel like, do I show people that, but I'm not just taking the test within the time limit with 5 minutes left on mod 2. I'm explaining it and taking it. And I remember I had somebody long ago, she's a testimonial on the channel from India. She's like, man, when I saw that you could do it and explain it within the time frame, she's like, of course I should be able to take it in real time and just take the test and knock it out. And she ended up getting like a 800 or a 790, something crazy. Bumped her score substantially. So it was really cool. All right. Anyways, here we go. Final test. I'm losing my voice. Hope I don't completely lose it. Three, two, one. Begin. Okay, for a particular machine that produces beads, 29 out of 100 has a defect. A bead produced by the machine will be cycled around. What's the probability that the bead is a defect? 29 out of 100. Boom. 29 for a particular machine. 29 out of every 100 beads has a defect. What is the probability? Yeah, probability is literally the number of defects over the total number. Boom, done. The equation gives the speed S in miles per hour of a certain car. T second. What is the speed in miles per hour of the car? 5 seconds. Okay, this is straight plug and chug, right? S equals 40 plus 3, and T is the number of seconds after it begins to accelerate. Plug and chug. 3 times 5 is 15, plus 40 is 55 for the win. Boom, done. Number 3, 4x equals 3. What is the value of 24x? Multiply both sides by 6. 6 times 4 is 24x. 6 times 3 is 18. 18 for the win. Boom, done. Number 4, scatter plot shows a relationship between two variables, x and y. Line of best fit is also shown. Which of the following equations best represents the line of best fit shown? So I have a positive slope, a y-intercept of around 3 point something, so probably 3.4. So this, hold on, is a negative y-intercept. This is a negative slope. This is a negative slope. This looks good. Positive 3.4, slope of 1. And let's see, is there anything else we can check here? When you plug in 14, you have 14 plus 3.4, which is about 17.4, which looks pretty, or 16 point, no, 17, well, it looks a little off, but it's not terrible. It should be up here. Okay. Well, whatever. The graph is slightly off, but this is by far the best one if you want to see the other ones. Yeah, impossible, impossible, impossible. Can't have a negative slope. Anyways, A is the winner, done. 300,000 paper clips, 234 large size. What percentage are large? Okay, so we got big numbers here. We got 234,000. Oops, 234,000 out of, what was it, 300? 300,000. And we get 0.78, which is 78%. That's how you do it. Let me just make sure I didn't misread it. Yeah, are large. Okay. Boom. The table shows 3 values of x and the corresponding values of y. This is a linear relationship. Which of the following equations represents this relationship? Again, you know what? I'm going to show you how to do this in Desmos. It's going to be negative 5x plus 18. Because I can see the y-intercept is 18, so it's got to be 18 or 18, and the slope, it's going down. Y is going down as this is going up, so it's got to be a negative slope. But, so you can see it in Desmos. This is a really cool method. If you get a table of values, watch this. Just type it in, 0, 18. For linear, you don't even need all 3. You just need 2. Quadratic, you need 3. So you'd finish the table. Linear regression, negative 5x plus 18. That's how you do it. Done. Very cool trick. Number 7. The function f is defined by this. What does the f of 2? That's plug and chug. Plug in 2. We get 2 squared is 4 plus 2 plus 71 is 77 for the win. Done. Which expression is equivalent to this? Okay, we are multiplying. So we add the exponents. M to the 4th times M to the 1st is M to the 5th. Q to the 4th times Q to the 5th is Q to the 9th. Z to the negative 1 plus Z to the 3. Negative 1 plus 3 is 2. That's our final answer. 592, 592. B is the winner. Boom, done. Triangle ABC is similar. Doop-a-doop-a-doop-a-doo. Are they right triangles? No, they do. I don't think they are. Okay. ABC, X, Y, Z, and let's just put it in A, B, C, X, Y, Z. They said AB is 170. Length of BC is 850. And in triangle XYZ, the length of YZ is 60. What is the length of XY? Okay. Obviously, I did it backwards in terms of which one's bigger and smaller, but it's all good. This is my unknown, and I did it in order. I'll call it B or something. I did it in order of corresponding vertices, so I can see the corresponding sides, right? 60 corresponds with 850. We go from little to big. Is equal to B over 170, little to big. We got a beautiful proportion. Now let's cross multiply and solve. Or we can do like this, if you guys like this better. We can go, hold on, 60 over 850 is equal to X over 170. So you can just straight up plug it in. It more or less solves it by that, and it's 12. 12 for the win, boom, done. Let's just see if that makes sense. So this is 1/5. Yeah, 1/5 of 60 is 12. It makes sense. X over 4 is equal to Y. X over Y, yowzers, is equal to 4. 24x over ny is equal to 4 as well. What is the value of n? Okay, here's the dealio. Look, I know it's 24 because If x over y is 4 and this is also 4, this needs to equal x over y. So what's going to make it x over y? We're going to need a 24 on the bottom, so those cancel out. So n has to be 24, and that's it. Moving on. 11, the function W models the volume of liquid in millimeters in a container t seconds after it begins draining from a hole at the bottom. According to the model, what is the predicted volume in milliliters draining from the container each second? Okay. So it's going to be 4, but this is just a straight linear equation, right? This represents the milliliters, and this is your slope, right? And look, we're saying it's starting at 300, but it's losing 4 because that's seconds each second. Plug in 1, you get 296. Plug in 2, you get 292. That's how you do it. Boom, done. 12. F is defined by this. For how many values of f of x? For how many values of x does fx equal 0? They're talking about x-intercept, so let's count them. 1, 2, 3. 3 is the winner. Boom, done. Straight polynomial x-intercept question. The given function estimates the species population x years after 2008. So 0 is 2008, 1 is 2009. Okay, 3,000 is your initial value, meaning when x equals 0. Meaning, in 2008, the population is 3,000. The estimated initial population of these species and area. What? Wait a minute. We're going to reduce the population. The function estimates the species population x years. So it's I don't know why they say species and area. Where's the area coming from? In an area, but like that phrasing is confusing me. Okay, it's not the decrease because that is this percent decrease is 25%. The estimated percent decrease for the population, no. The estimated population for the species and area, 8 year, no, that would be plugging in 8. So 3,000, the estimated initial population for these species and area. Okay, fine. Why did you say population? That's what confused me. But anyways, D is the winner. That's how you do it. The given equation relates variables x and y. For what value of x does the value of y reach its minimum? I'm going to straight up plug it in. That's going to be the easiest. Y equals x squared. And the value of x is 7. That's how you do it. Okay, square A has side lengths that are 166 times the side length of square B. Okay. The area of A is k times the area of B. What is the value of k? All right, look. Again, as I mentioned, if we have a ratio of the sides, we know the ratio of the areas are each of these squared. So that's it. Area of A, square A is k times square B. So square B is going to be whatever 166 squared is. We're going to multiply B times that, and we get A, and it is 27556. You could have also chosen values, right? The easiest way is just to say x is 1. I mean, I usually don't like 1, but, and then A is 166 times 1. Then calculate the areas of each, and you'll see, like, you know what I mean? K times 1 is equal to 27556. So K is that. 16. Here we go. Solution to the given system of equations is AB. Doop-a-doop-a-doo. Okay. This one I'm not going to use in Desmos because they gave us a layup. I'm going to negate the top one. Negative 2A minus 8B equals negative 198. 2A plus 4B equals 98. We're going to now add them together. Goodbye. Negative 4B is equal to negative 100, right? Negative 198 plus 98, negative 100. Divide by negative 4B equals 25 for the win. Boom, done. And if B is 25, just for fun, that'd be 200 negative. So negative, A would be negative 1. I'm just going to double check. Negative 1 is negative 2. Yeah, it works. 17, the function is defined by this. What is the y-intercept? Plug in 0 and solve. That is it. Or plug it into Desmos. I'm going to plug in 0 and do it mentally just for fun. 2 to the 0 is 1 times negative 8 is negative 8. Negative 8 plus 22 is 14 for the win. Done. You know what? Let me just be safe. I don't even know why I'm doing this, but I want to try and get all of these right on this last go. There's my nice y-intercept, double verified, done. Two variables, x and y, are related such that each increase in the value of x Each increase of 1 in the value of x, the value of y increases by a factor of 4. So as x goes up by 1, y goes up by, and that's times 4 as a factor of 4. Basically what that's saying is it's d. It has to be 4 in there. But then they give us this other point, 0 and 200. So look, if I plug in 0 here, I get 0. If I plug in 0 here, I get 4. Both of these are out. If I plug in 0 here, I get 0. Okay, well, all of these are out. But if I plug in 0 here, I actually get 200. And but then increase by a factor of 4. Think about it. You then take it to 1, you're going to get 800. It's increased by a factor of 4. Factor of 4 means a multiple of 4. That's how you do it. What is the value of this? Now, some people say, hey, do we need to know the unit circle? I mean, kind of. If you could use the unit circle for this, because you could say, you know, the what's it called, coterminal angle of 42 pi, you subtract a bunch of 2 pi's and you get sine of 2 pi, or sine of 0, and we know sine of 0 is 0, or you can just do this. Make sure you're in radians mode. Sine of 42 pi, whoops, is equal to 0. And if it gave you a weird decimal, then you could just check it against these decimal equivalents and you'd be good to go. In the given system of equations, h is a constant. Hold on one second. If the system has no soluciones, meaning the lines are parallel. Okay, so the top one, I'm going to get into slope-intercept form. I'm going to add 9y, so I get 18y. I'm going to subtract 5 from the other side simultaneously. And then we're going to divide by 18. I'll move it around. We've got 4 over 18, which is 2 over 9x minus 5 over 18. So what did I do? I just divided both sides by 18, right? And that's how I got this. I just flipped it around so we get it into the more traditional slope-intercept form. So that means for the bottom equation, let's get that one into slope-intercept form by dividing by h. We got 4 over hx plus 2 over h, and we need these to be the same. Now, this is what I was saying before earlier in the stream. I'm not really going to focus on the y-intercepts because if we get an h value that gives us the same slope, they're going to set it up so the y-intercepts have to be different. Otherwise, you can't solve this. So I'm not even going to bother looking at this. So I got 4 over h must equal 2 over 9. Cross multiply 2h equals 36. Divide by 2, h equals 18. And that is how you do it. You can graph it if you want. Oops, you can graph it if you want to double check. But if h is 18, yeah, we get the same thing. Okay, 2 left. I'm really losing my voice here. One solution. Okay, they're writing a solution like this, right? It should tell you that we're using quadratic formula to solve this. And you can see it's not factorable. Quadratic formula is negative b, which is negative 2, plus or minus square root of b squared, which is 4, minus 4 times a, which is 1, times c, which is that negative 9, over 2a, 2 times 1. Okay, so now we get 2 plus or minus. This is going to be negative times a negative is positive. 4 plus 36 is 40 over 2. And we wanted to get into the format of 1 plus rad k. Well, 40 is 4 times 10, so I can take the square root of 4, which is 2. So I get 2 plus or minus 2 rad 10 over 2, divided by 2. 1 plus or minus rad 10. And now it matches exactly k is equal to 10. That's how you do it. Last one. In the given equation, c is a positive constant. Oh, they brought this one back. This was on one of the earlier tests. Okay, so the way I like to do this, you can use Desmos for this. It's a pretty hard question, but I haven't solved this one in a while. I remember what I used to. Oh, yeah. This is the easiest way, in my opinion. So I'm going to subtract this from the left side. So I get x squared minus c squared. We have common denominator, so it's all over x squared minus c squared. Now, you could also look at this as the same thing. That's x squared minus c squared to the 1 on top over x squared minus c squared to the 1/2 on the bottom. Same expression. Guess what? I can subtract those exponents. I get x squared minus c squared to the 1/2 is equal to 39. Look how amazing this is. Now, we want to just solve. We're trying to solve for x. So now we're going to square both sides. X squared minus c squared is equal to 39 squared. That gets rid of this. Then we're going to add c squared. Boom, boom. And then we're going to square root, and we got it. Square root of 39 squared plus c squared. But it's plus or minus, so we can take the positive or the negative. They gave us the negative there. That's how you do it. We got them. We got 20 minutes, but I'm not going to use the time. Let's check it out. We're going into mod 2, ladies and gentlemen. Final mod of the stream. If you guys are watching and haven't liked the stream, please click that like button. It helps a lot. All right, here we go. An airplane descends from an altitude of 9,500 to 5,000 at a constant rate of 400 feet per minute. I can create an equation for this, right? It's dropping at this rate. What type of function best models the relationship between the descending planes? Well, it says constant rate, so it's got to be decreasing linear. That's it. Done. Let K is defined by Y is equal to, this is line K, this is line J. It's parallel to K. What is the slope of line J? Parallel means same slope. Slope is right there, 17 over 17, which means B is the winner. Same slope. Boom, done. It's 3. Caleb used juice to make popsicles as the function. Approximates volume of fluid ounces had remaining after making X popsicles. Which statement is best interpretation of the Y-intercept? So that means that's our starting value. Initial value, 30. This is the amount left. This is the volume. So that means we have 30 fluid ounces before making any popsicles. Initial value. Nothing involving the 5. When he began. Nope, not per. It's at the beginning. It's the initial. C is the winner. The equation gives the estimated height of the toy rocket X seconds after its launch. What is the value's best interpretation of the vertex? Boop. It's going to be the max height. So the vertex is going to occur, since this is in vertex form, it's going to be at 5.6, comma 502. So the max height is going to be 502, which is reached at 5.6 seconds. Nope, not 16 seconds. Estimated max height of 502. Yep. Toy height reached the estimated max height. Nope. I know these are wrong, but toy height reached the estimated max of 5. Nope. Right? They flipped it around. X is your seconds. Again, excuse me. You could plot this in Desmos and figure it out that way, but that's how you do it. Okay. Function f is defined by this, where f of x is equal to 4x plus k times x minus 1. F of 5 equals 32. What is the value of f of 10? So we know that when x is 5, we can solve for k here. When x is 5, the function is 32. 20 plus 5 minus 1 is 4. So that means 12 equals 4k. So k equals 3. So then we can simplify this. F of x equals 4x plus distribute the 3. 3x minus 3. So we get 7x minus 3. Plug in 10. 70 minus 3 is 67. Let me just make sure I didn't make a mistake here. 4x. What did I say? K was 3, right? 4x plus 3 times x minus 1. And we said f of 5 is going to equal 32. And that's right. So then f of 10, let's say this is f of x. F of 10 is 67. Boom, done. Number 6, here we go. A, B, C, and D if are congruent. Okay, it's right triangles as well. Bop, 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 bop. Boom, boom. B and E. A is 18. That means D is 18. F and F. They have to be complements, so 72 and 72. What is the measure of angle F? We got them just like that by filling out the diagram. That's how you do it. Done. And that's how I do those. I fill them out. Doesn't take too long. Then I find the right info right there. Which of the following XY is a solution to the given system of inequalities in the XY plane? Okay. Well, I got an inequality problem wrong before, so I'm probably going to double check this one. But I like to normally just plug and chug. Negative 14, 0. 0 is less than negative 7. Yes. 0 is greater than, nope, that doesn't work for the second one. Negative 14 is less than 7. That is false. 14 is, what am I saying? Oh my God. Negative 14 is less than 7. Negative 14 is not greater than negative 1. 14 is not less than 7. 0 is less than 21. 0 is greater than, yeah, it's D. Now we're going to double check so I don't make a mistake this time. You know, I should have done that last time. I just was, you know how it goes with these live streams. Okay, greater than or equal to. See, to write greater than or equal to, I write the greater than and then I type equal. negative 2x minus 1. So the solution that we were vetting was, what was it again? 14, 0, right? And the double shaded portion is the solution set, and there's 14, 0 right there. You can see 14, 0. It's in the double shaded. We're good to go. That's how you do it. Boom. The dot plot represents distributions of values in data sets A and B. Which of the following statements must be true? The median of set A is 13. It's the middle value. Is equal to the median of set B is also 13. It's the middle value, right? And these are symmetric plots, so it's pretty easy to spot them. So they are equal. So 1 is true. Not this, not this. Now the question is 2 true? Standard deviation. Standard deviations are not equal. That's the spread. They have different spreads. Notice this one is more concentrated at the center. This one is not. So 2 is not true. 1 is the winner. Boom, done. Scientist initially measures 12,000 bacteria in a growth medium 4 hours later. 4 hours later, that funny meme, or whatever. The scientist measures 24,000. So it's doubling. Okay, so watch this. This is my initial. It's doubling every 4 hours. Okay. Assuming exponential growth, the formula is this, gives the number of bacteria in the growth medium where R and C are constants, and P is the number of bacteria. What is the value of R? Oh, okay. Well, I just did it, essentially. It's 1/4. Okay, so if you know how an exponential works, right, this is my initial value, which is 12,000. Oh, and they gave me 2. See, I didn't even see that, but they gave me 2. And then so instead of playing their game and writing out RT and figuring out all that, I know in 4 hours this should be 24,000. So that means this would have to be 1 when x is 4. So it has to be x over 4, and that's the same as 1/4 times the time value, which they said is t. So R is the 1/4, and that's how you do it. A cube. Let's draw the cube. X. All the sides are equal. That's the volume of this. What is the surface area? So first of all, I need to find the side length. So volume is x cubed, and that's equal to this. Let's take the cube root of this value to solve for x. I'll show you how I like to do cube roots. 4, 7. To the 1/3, that's a cubic root, right, is 78. X is equal to 78. Excuse me. Now, sorry for the coughing, guys. Now, for surface area, I don't advocate memorizing the formula. Just think it through logically. We take the area of one face, which is 78 squared. And how many faces are there? 6 of them. So it's 6 times 78 squared. That's it. 6 times 78 squared, is equal to 36504. For the win, boom, done. Number 11. Here we go. The solution to the given system of equations is this. What is the value of 8x plus 7y? All right. Oh, again, this is a layup, okay? We're not going to solve for x and y individually. Just add these 2 equations together. These will cancel out. We get 8 times 7y is equal to 24. So 7y is equal to 3, okay? And I'm going to solve for 8x directly. I'm not going to solve for x. So I'm going to replace this top one with 3. So we've got 2 times 8x plus 3 times 4 is 12 equals 12. Cancel. That means 2 times 8x is equal to 0. So 8x is equal to 8x is equal to 0. And so 0 plus 3 is 3. We're going to double check that. 3 is 12 plus 0. Yep, it works. Boom, done. Yeah. Number 12. A certain time is the area of this. What is the area in square yards? Okay, so we're going to do this again. Definitely going to see one of these on the test. I can almost get, they keep throwing these ones out here. So we got 4.36 miles squared, and we want to convert it to square yards. So again, they're giving us the ratio of miles to yards. So I don't want miles to yards. I want miles squared to yards squared. Well, that's not too bad, because to get the equivalency, I take the length equivalency and I just square those values. That's it. And now we can do the conversion. 4.36 times 1760 squared And we get this huge number, 13 milli. D is the winner. Boom, done. Number 13. Here we go. PQR. Are they... Oh, man. It's going to be a graph. Okay, hold on. How can I do this efficiently? PQR. Hold on. The measure of Q. Oh, what am I doing? Let me just go straight to Desmos. Hold on. So we've got... Here, watch this table. And then we're going to do this, and we're going to say, well, let me turn the line on. Okay, so let's see if this is going to be the most efficient here. So we got 4, 5, 4, 7, and 6, 5. And then I'm going to put the first one back so it connects back. So we've got a nice triangle. Oh, it's a right triangle. Nice. And then the other triangle... Okay, I think I get it. Table. I haven't seen one like this before. This is very interesting. So the other table, another triangle, excuse me, is 4, 5, starting at the same spot. 4, and then 7 plus K. Can I not add a constant here? And then we got 6 plus K and 5. All right, and then we want to go back to 4, 5. Oh, it's not doing I can't add a slider for K? Wait, let me try C. No. Okay. Okay. So what they're saying is, oh, but then you can just plug in these. No. Wait. Hold on a second. Oh, so it doesn't matter. These are going to be similar. Look, I'm going to choose an arbitrary value. I'm going to just choose 2 and 2. Okay, it's not going to matter because they're going to be the same. You can see it's increasing that one and that one by the same sideline. So we're getting similar triangles. That's the point. Now, okay, so they want the measure of angle Q, PQR. So Q is 4, 7, which is up there, right? So they want that measure. And Q, oh, no. Yeah. So they want Q is, wait a minute, this is a 45, 45, 90. Okay, oh, this is such a weird problem. Okay. So, I've never seen one like this. So Q, let me do this. I'm going to have to pop this over here because we need a diagram that I can write on. So we've got 4, so this is 4, 5. So this is P. Q is 4, 7. No. This is P. This is P. This is Q, 4, 7. And this is R, is 6, 5. Okay? 6, 5, 4, 5. Oh my God, this is taking way too long. And then we want, if the measure of Q, which is up here, is T. So T is 45. What is the measure of N? So for N, it's L is 4, 5. M is 4, 7 plus K. So this is M. And then N is here. 6, right? 6 plus K. Oh my God, why is this confusing me so much? Okay, so then it's the same. It's T. It's 45. Oh my God. It's just 45, which is also equal to this. The K involvement in the angles makes no sense. Yeah, it's that. What a weird problem. Okay, anyways, a small business owner budgets $2,200. Oh, I'm in red now. Let me get rid of that. Budgets $2,200 to purchase candles. The owner must purchase a minimum of 200 candles to maintain the discounting price. If the owner pays $4.90 per candle to purchase the small candles. Oh, wait, hold on. We got small, large. We got $4.90. Oh my God, it looks like $9.90. $4.90 to purchase small and $11.60 to purchase large. We'll call this X and Y. And what is the maximum number of large candles the owner can purchase to stay within the budget and maintain the discounting price? So what we have is we have X plus Y needs to equal 200. And then we have 490X plus 1160Y is equal to 2,200. Now, again, it's a minimum, so it may not actually be equal. So we say This is a minimum greater than or equal to, and this is less than or equal to technically. I don't know if it's going to intersect exactly. I'm guessing it's not because it's mod 2, and they're going to make it a little harder. So that's why we'll do it like this. So let's take a look here. Greater than or equal to 200, 4.9x plus, oh, let me move this up here. You can't see what I'm doing. 4.9x plus 11.6 y is greater than or equal to 200. Okay. So we have these systems, and we're looking at the inner. Wait, did I do this wrong? Oh, I said 200, not 2,000. Sorry. And we're looking at the intersection. Yep, see, it's a decimal. So we want to know the max value. And what we have for this intersection point is 47.7, 152.23, right? 47.23, something like this, okay? So there's that coordinate, but we can't purchase partial things. And again, we need to have a minimum of 200. So, and then we need to be less than 2,200. So we can play around with this, right? We want the largest number of large candles, which is my Y value. So let's see if we can get 153 and 47. Now, when you look at this, oh, it's actually right on the line. So yeah, so I guess it's 153 and 47, 154 and 47 gives us, wait a minute. Did I type this in wrong? Oops. Oh my God. I'm losing my mind. That was supposed to be less than. I'm like, how is that also working? Okay, sorry. 153. Sorry. But it's on the line, but it's not in the double shaded, right? So that doesn't work. So 153 is going to be too high. And again, there's no way, right? 48, 49, that's out of it. So 47, we got to get in that double shaded zone, or so we could do 152, but again, it has to minimum add up to 200. And there we go. We could do 152 and 48. It's right on the money. So 152 is going to be the max amount, right? As soon as we get to 153, as I mentioned in 47, we're again out of the double shaded. So 48, 152 for the win. Boom, done. Okay. And then if you want to double check it, again, those two add up correctly, just to see 4.9 times 48 plus 11.6 times 152, and we get just under 2,000. There we go. I typed that in right. Yeah, 152. Okay, we got 6, 7, 8 problems left. Square is inscribed in a circle. Let's draw it out. Hold on. So we got this. We got this. Okay, whatever. Looks good enough. Okay, so we got a square inscribed in a circle. The radius of the circle, as soon as I hear radius, I'm drawing in a little diagonal thingy. This is just from years of practice. You just recognize that we want to somehow like get this, I could also draw it like this, but we want it to be valuable with respect to the square as well. And this is the way to do that. In fact, what I'm going to do is I'm going to draw this straight across as a diameter. So the radius, if you divide by 2, it's 10 rad 2. So the diameter is 20 rad 2, right? And then what is the side like? Okay, look, this is it. We did it already. This is a square. These sides are equal. What is this? This is isosceles right triangle. It's a 45, 45, 90, meaning if this is the hypotenuse of the triangle, if I divide by rad 2, I get the side lengths. It's 20. We got them. A is the winner. Boom, done. Right? 20, 20, 20 rad 2. Half of that is the radius because of the radius. Yeah, we're good to go. 16. Here we go. Which of the following equations represent a circle in the xy plane that intersects the y-axis at exactly 1 point? Now, you can plug these all in Desmos and solve it that way. Let's see. Okay, I'm going to do it a little bit more slick, okay? I'm going to do it faster. This is centered at 8, 8 with a radius of 4. It's not going to touch it at all because it's 8 away from the y-axis with a radius of 4, it's not going to touch it. This is at 8 with a radius of 4. Again, it's not going to touch it. This is a radius of 4. I'm sorry, a center of 4. If this is the 1, it's going to be centered at 4, 9. That's the center, and it's a radius of 4, so it's going to just touch that x-axis, y-axis at one spot. It's going to go blop like that. This one is going to be centered at 0, 9. So it's right on the y-axis, and it's going to have a radius of 16, but it's going to hit it twice. So C is the winner. That's how you do it. Done. 17, one of the equations in a system of 2 linear equations is given. The system has no soluciones. Okay. So no solution means same slope, different y-intercept. If I add this over, I get the exact same line. That's infinite solutions. Add this over, I get same slope, different y-intercept. Add this over, I get 12. Let me make sure. No solution. Yeah, 12x, 12x. Oh, so it's got to be B for the win. Done. 18. Oh my goodness. Which one is equivalent to this? Now, you can plug this in and plug these in and see which one's the Zave. That's a lot of work in the calculator. Instead, I know what they're trying to do, right? They want us to have common denominators here. The way they get these common denominators is they just do this times this. That's it. And I'll prove it. X squared y minus 8xy. If we do a little foiling, we get 8x cubed y minus 8x squared y minus 8x squared y, which will give us negative 16 x squared y, and then plus 64 xy. And that is what they, and that's what they have here and here. So it's got to be A or D. I'm kind of assuming that's what they're doing, but like it's what they always do. So, I mean, it's got to be one of those two. Then, how do they get those common denominators? You multiply this by that numerator, that by that numerator, and then you combine like terms. So we got y plus 12. Because all we got to do is figure out the numerator. X squared y minus 8xy. And then plus y times x minus 8 times x minus 8, which makes that squared. But let's write it out like this. Yowzers. It's a lot of work. Here we go. Oh, yeah. Okay, so we got x squared y squared minus 8xy squared plus 12x squared y minus 96xy. And then we're going to add it to this one. Let me FOIL this out first because that's a perfect square trinomial. It's x squared minus 16x plus 64. If you FOIL it out and combine like terms, that's what you get. And you get boop, boop, boop. And then we get, oh my gosh, sorry, I'm just trying to hustle here. We get x squared y minus 16xy. And then we get plus 64y. If you guys know of a faster way to do this, and if I've totally blown this, let me know. I can't think of anything faster off the top of my head, so we're going to just roll with this. Now, let's combine like terms. We got like term, like term. We've got like term, like term. Is that it? 8x squared. I make a mistake. Did I? 8xy. I don't think so. Okay. Yikes. So we've got x squared, y squared. Uh-oh. How did I get an x? Let me make sure I did that wrong. Didn't do that wrong. Oh my God. Oh no, that's how I got the denominator. And then I got y plus 12 times x squared y minus 8xy. Is there a difference here? Okay, this is really weird. So then I get x squared y squared. Why did none of them have an x squared y squared? Yx. X squared y squared. And they didn't simplify that denominator. And none of them cancel out. 8xy squared. Okay, let me just combine. I don't know what's going on. I feel like I did something wrong. X squared y squared minus 8xy squared. And then we have plus 13x squared y minus 102 minus 112xy plus 64y. This is very bizarre. I really think I made a mistake here. Because how am I getting this strange thing? Oh, I know what they did. Oh my God. So bad. Okay, hold on. Revamp time. What they did was they factored out a y on the bottom and canceled that out to simplify this first. So look, so it's probably not actually A or D. Oh my God, this is so bad. Sorry guys. Okay, this is a bit of an interesting twist. X squared minus 8x. So this is what they did. And then it's so much easier. Oh my God. Hold on. They factored out the y and the y's of the y's are gone. And then we have x minus 8 over x times x minus 8. Then we get 1 over x. Holy smokes. So then this is so much easier. Wow. Y plus 12 over x minus 8. We're adding it together. So I multiply that by x. I get xy plus 12x. This one I do x minus 8 plus x minus 8. And then we get xy plus 13x minus 8. And then the denominator is just x times x minus 8. X times x minus 8. So this is my correct answer, but they don't have it. But then what they did is then they took this and they multiplied everything by y, right? Because then that's x squared. What the heck? This is kind of a hard problem, honestly. And then they did a y, and it's c. Woo! Let me know what you guys think about that one. That one was very difficult in my opinion. I don't know. Maybe you disagree. The given equation relates positive variables P, Q, R. Oh my God, I got to hustle. These are hard. Which is the following is equivalent to Q? Okay, so it's an isolating quantities question, but they made it very difficult. And we're going to need common denominators. So we're going to get denominators of Q, R, S on this side. 20P is equal to multiply this by RS. 20RS minus 20. I got to hustle here. QS and then minus 20 QR. And that, but because I'm multiplying each one individually by the missing pieces, and then we get a nice common denominator of QRS. And then we need to isolate Q. So then we're going to, what should I do here? Then if we multiply by P. Okay, let's multiply by QRS. 2QRS is equal to 20 PRS minus 20 PQS minus 20 QRP. And then we need to get the Q's over here. 20 QRS plus 20 PQS plus 20 QRP is equal to that remaining thing, 20. Oh my God. And then we got to divide everything by, we got to factor out the Q. And then we get to divide by 20 RS plus 20 PS plus 20 RP is equal to 20 PRS. So when we divide everything over, we get the 20s are going to all cancel out. PRS over RS plus PS plus RP. Yowzers, it's C. That was insane. Sorry I'm going super fast, guys. I only have 6.5 minutes left. Okay, 3 problems. Here we go. In the equation, K is an integer. If the equation has no real solution, that means this can, it's a quadratic. No, sorry, what am I saying? Kx squared minus 56x plus 16 is equal to 0. Discriminant would be negative, right? So B squared minus 4AC is negativo. So then that's negative 64K. And then we got 56 squared. What is that? Hold on, I got to hustle. 56 squared is 3136. So it's negative 64K is less than negative 3136. Divide by 64. And that's a negative, so it flips the inequality. K is greater than 49. K is an integer. What is the least possible value? It is greater than that, so it has to be 50. Boom, done. All right, let's go. I would check that if I had the time. Maybe I will if I go back. Let's see. For each real number, R is, oh my God. All right, these problems are really hard usually, but I've done them before. It might actually be a repeat of the same one. So the bottom line is if you multiply top one by 5, it's the same equation, okay? So it's just 2x plus 3y equals 7 on top of each other, right? And so they have infinite solutions. So the solutions are basically any solution that works out to this. So what we can do here is it's either like, look, they've either said if X is R, what is my corresponding Y value? So you either have to isolate X or isolate R, or isolate Y. So if I isolated X, right, and I would say X, or sorry, what am I saying? If I isolated Y, I get 3Y equals negative 2X plus 7. Y is equal to negative 2 over 3X plus 7/3. So if my X is R, my Y should be negative 2/3 R plus 7/3. Negative 2. So I don't have that. So it's not these two. So then what they did is they isolated X basically. So then to isolate X, we get 2X is equal to negative 3Y plus 7. And then X is equal to negative 3Y over 2 plus 7 over 2. So when Y is R, we get negative 3 over 2 R. Yeah, so it's B. B is the winner. Boom, done. Okay, we got 4 minutes. We got to hustle. Okay, Windows Specialist charges a fee of $220 for the first 2 hours of repair and an hourly fee for each additional hour. Total cost for 5 hours is $400. Look, this is a linear equation. Okay, I got 2 coordinates. All I need to do is create my equation for my line. I'm going to show you how people get tripped up on this a lot. But if I subtract these two, I get negative 180 over 2 minus 5 is negative 3. So I have a slope of 60, which means C and D are out. And then I can use point slope. I could also plug this into Desmos, but whatever. I'll just keep it from here. Y equals 60x plus B. No, not point slope. Slope-intercept form. I'll just do this. Plug in 220 for Y, 2 for X. Sorry, that's equal, not plus. Plus B. B is 100. So we know my equation is this. The other way you can do it is you have these 2 coordinates. Just see which one of these equations it works for these coordinates, because these are legit. For 2, I get 220. 2, I get something weird here, 340 or something. For 2, I get 160. Makes no sense. For 2, I get, something weird. So right off the bat, with 2, 220, it's out. But then for 5, I do get 400. For 5, I don't. For 5... I don't get 400. So then you could come down to these two with the 5, 400. But this one, yes, it matches for both. 2, 220, 5, 400. A is the winner. Okay, we did it. Let me see. I hope I really tried hard to not make any mistakes here. This is the one I guess I can double check. So let's just do it. I did it fast. So we get X times 50, X minus 56. And then Y equals negative 16. So we're going to see if there's no solution here, right? So far it looks correct. If I change that to 49, yep, now we have a solution. See? So, or maybe 2 solutions. I don't even know. But yeah, so it has to be 50. That's the minimum value. And then 1, 2, those are all going to work, right? You see? Okay, so that one's verified. I guess let's just go for it. And then I'm going to answer questions at the end here. Guys, like this stream. I'm losing my voice for you. If you haven't liked it, please like it. All right, for the final one, let's see if I got them all or not. We are about to find out, ladies and gentlemen. Oi, oi, oi. Okay. Let's view the score here. Once again, it's going to make me log in. I'll log in off screen. Do 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 do. Where's my scores? What? No, I missed one again, ladies and gentlemen. All right, it is what it is. Let me see what I missed. Let's see. What did I get wrong? Boop. Let's go to math. All right. See, again, I told you, right? They're all maxed out, even though I got a mistake here. Let's see. What did I do this time? What? 14? What the heck? I thought I got this one wrong? That's very confusing. Hold on a second. Huh? Wait. I'm very confused. Okay, hold on. Let me see if I can. What the heck? Okay. I'm going to do this again. Let me go into Desmos here. So what did I type something in wrong? Okay, so it said the large candles. Wait, where was it? Okay. Let's put it over here. The large candle, so we said we have budget's 2200. So I said 4.9. Okay, let's do it one more time. 4.9x plus, what was it? 11.6y is less than or equal to 2200, right? And then my other equation was x plus y has to be greater than or equal to 200, right? Wasn't it 200 candles? Minimum of 200. And I took the intersection. What? I have a different intersection now. I swear it said 152. I must have had a typo. Okay, here's the lesson, guys. Lesson learned. On these free response questions, you have to quadruple check your inputs, because you do something like that, I'm hosed, right? I didn't double check the values, and that was my mistake. I do always say to double check and triple check and quadruple check when it's free response, because you have no idea then if you're not on the right track, there's no multiple choice answers to guide you. So unfortunately, I kind of blew it there, but you can take that learning lesson away. I don't even know what I typed in. Let's see if anybody has it in here. This is practice test 10. Hi, bro. You're my favorite tutor. Hey, mama. Thank you so much. You're welcome. Can we plug in a random value for C? Yes, you can. Got test tomorrow. I'm nervous. All right. Ladies and gentlemen, we are done. That was a long stream, okay? And we got through practice tests 8 through 10. Those are all the new ones. Now, let's talk about conclusions here. Let's talk about predictions. When we look back at these problems, here, let me show you the ones that really stand out to me. Let's check this out here. So we're going to get through, let's go through all of these. I'll tell you the ones that kind of popped out in my mind. That's pretty standard. Those are pretty standard. So, of course, you'll expect to see those. Line of best fit, those are going to be there always. And notice what I did with the line of best fit. I was able to quickly eliminate based on the slope and the y-intercept. That's just standard. This one is nothing special. Plug in, nothing special. We're definitely going to have some similarity. Notice how I drew out the triangles. You draw them out with the corresponding vertices in the same order, plug in the information, and usually the answer will appear. So you got to be down with similar and congruent and the difference between those two. They always have those proportion problems, nothing crazy. Finding the number of zeros of a polynomial, just understanding what that means, right? When it's equaling 0, x-intercepts. We had a lot of those exponential, but nothing crazy. Minimum, you know what to do for those. Plug it into Desmos. They had a lot of this. I definitely think you're going to see, if we know the side length ratio, how do we convert to the area ratio, right? Side length ratio is 1 to 3 or 2 to 3. Area ratio is 2 squared to 3 squared. Remember that. Very important. Nice system of equations. Nothing special there. Y-intercept of exponentials. Usually it's that front value, so you might think -8, but here they tricked you with 22. But the main thing is for any function, y-intercept, plug in 0, solve. That was a nice trig function, but you just plug it into Desmos, no problem. No solution. They've been doing that a lot, but that's a common one. Same slope, different y-intercept. This is when you see something like this, immediately think quadratic formula. This is an oldie that they brought back, and that's that. All right, so then we're going to go into mod 2. Yeah, decreasing exponential. This is, again, parallel slope versus perpendicular. They had one questioning perpendicular as well. I didn't see any product of solutions, but I did see a place where you could use sum of solutions for a quadratic, just FYI. Interpretation, obviously, vertex form, got to know that. This is just a standard function, plug and chug. Again, congruent triangles. These systems of inequalities very common. That was even that word problem that I got wrong because I made a typo. Standard deviation, I think this is going to be there. Converting, remember I said comparing standard deviations, all about the spread. All right, this is volume to surface area. So again, you got to find the side length. Draw out a diagram. That's the key for these, drawing out a diagram. Okay, solving a system, but keeping it in terms of 8x and 7y, if you remember that one. We're going to timestamp this video, and you're going to be able to go back and watch each question. This one was a really funny one. That was a really good one. Again, what did I do is I plotted it in Desmos. I probably could have plotted by hand. It would have made more sense. But then once I got my head around what it was really asking, it wasn't too bad. This was the typo. Still don't know what I typed in. That's embarrassing. This one, I made a nice diagram. Got it. This one, we need to know standard form of circle. But the good thing is you can plug it into Desmos and it'll graph it for you, so no big deal. Same idea. This was crazy. So I guess the moral of the story for this one is simplify. Look for ways to simplify before you just start cross-multiplying and doing all that stuff. Again, if you're looking for equivalency, you could have also chosen values of x and y. And like x is 3, y is 4. Plug it in and see what you get here. And then whichever expression you get the same output, you know that's correct. If you get two hits, then you just choose another xy coordinate pair and run it again. So that's another way to get around this without having to do all the algebra. This was tough. This was very tough. You saw how I did it. I had to do it fast, but I basically got common denominators, brought the Q over there, isolated, and yeah, but that's a really hard isolating quantities question. They've been doing those lately, so be on the lookout for that. No solution. Again, one solution, no solution, two solutions. Think discriminant. Yeah, these are nothing new, right? But again, it's a linear equation. Find 2 points, get it, boom, done. Okay, guys, I got to call it a day. I am losing my voice. Good luck to everybody. Hope you guys appreciated that. Again, if you haven't clicked that like button, hit that like button and let me know tomorrow how this test goes. All right? Thank you guys so much for joining. We'll see you in the next video. Take it easy.